Hello everyone, welcome to Simplilearn's YouTube channel. If you're here to learn Java, then you're at the right place. This Java full course will include all the major fundamentals based on Java programming language. So before diving into that, I would like to let you know guys that we have daily updates on multiple technologies. If you are a tech geek in continuous hunt for latest technological trends, then consider getting subscribed to our YouTube channel and hit that bell icon so that you never miss an update from us. So without further ado, let's begin with the agenda for today's discussion. So at first, we will go through a brief introduction of Java, followed by that we'll learn the installation of Java in your local system. Next, we'll learn what exactly is a Java development kit, followed by that we'll install Eclipse IDE into your local system. Then we will go through some major fundamentals of Java. Then we have the object-oriented programming concepts in Java, and inside that we will learn the Java abstraction, Java encapsulation, Java inheritance, Java polymorphism. So once we are done with the object-oriented programming, we will dive into the next segment where we will learn the data structures, or otherwise called as Java collections. Then followed by the Java collections, we have the exception handling in Java. Followed by exception handling, we will dive into Java database connectivity. Once we are done with the Java database connectivity, we will enter the Java servlets. Once we are finished with the Java servlets, we will have the Java application programming interface. Then we have the Java Enterprise Edition tutorial. Followed by that, we have the JUnit tutorial. And finally, to make things better, we will also go through some most frequently asked Java interview questions. Now, I hope I made myself clear with the agenda. Now, escalating over to our training experts.
In today's era, the internet and smartphones have become an integral part of our lives. We use our phones for almost all of our day-to-day tasks. Earlier, we used to shop at malls, queue up in front of banks, and make our travel bookings at travel agencies. But now, we can do all this in the comfort of our homes using smartphones. All of this is possible because of a high-level programming language called Java. Hi guys, welcome to this video that will tell you everything you need to know about the class-based, object-oriented programming language Java. Java is an object-oriented programming language that is used in a distributed environment on the internet. It is a high-level language that is easy to read and understand. Java is popularly used in console, graphical user interface, web and mobile applications, game development, and also to make embedded systems. Apart from these, Java is also used to develop software for devices. It is used not only in computers and mobiles, but even in electronic devices like televisions, washing machines, air conditioners, and so on. Online forms, banking, and shopping are possible because of Java. Java is a computer-based programming language invented by James Gosling and Sun Microsystems in 1991. He had a single motto while creating the language. It was write once, run anywhere. This meant that the code would have to be written only once, but it could be used anywhere. They named this language Oak because of the oak tree outside Gosling's office. Later, it was named to Green, then to Java Coffee, which was named after the coffee from Indonesia, and finally to Java in 1995. There are 3 editions of Java. Each programmer can learn any of these editions based on the application they want to make. Firstly, we have Java Standard Edition. This edition contains core libraries like java.lang, java.util, etc. Secondly, we have Java Enterprise Edition. This edition has APIs like JMS, EJB, JSP, Servelets, etc. And lastly, we have Java Micro Edition, which is used to program Java in cell phones, set-top boxes, handhelds, and so on. Java is an object-oriented programming language based on C and C++. However, it is improved and simplified to solve the errors in programming. Java files are converted to bitcode format using a compiler and then executed by the Java interpreter. The whole Java code is run on the Java virtual machine, which provides a runtime environment. Now the main concepts in Java are its methods and classes. A method is a block of code that performs a task only when it is called. Consider this example. While watching TV, you use the TV remote to change channels. Each button on the remote performs a different task. Methods in Java are the same. We can have methods to add 2 numbers or email a person or to convert kilometers to meters. A group of methods make a class. Classes are used to organize code just like how fruits, vegetables, and clinical products are divided into different sections in a supermarket. There are a lot of features in Java. Let's start by looking at them one by one. It has a simple syntax and is very easy to understand and learn. Java language is robust. It eliminates errors that occur in the C and C++ languages. Java also has features like garbage collectors and exception handling. This makes Java very unique. The most popular feature of Java is that it is platform independent. Here, compilation happens in bytecode, and because of this, Java can run on any machine. It is a very secure language as it contains no virus. Java has a feature of multi-threading. The feature of multi-threading helps Java do multitasking. Java is a portable language as it can run on any platform, and data type sizes are set permanently. So Java program has a fixed size of the code. The last of all, Java is not as fast as C and C++, but provides higher performance than any other language. Now let's see OOPS concepts in Java. Java has 4 concepts: abstraction, encapsulation, inheritance, and polymorphism. In Java, we use objects and classes related to the real world that makes the code easier to make and understand. Abstraction means showing the relevant information that is needed for a task. Encapsulation makes the Java code secure. Data is stored within the classes, and it is not easy to access the data. The next feature is inheritance. As the name suggests, the attributes and characteristics of one class can be inherited by another class. Because of this, coders take less time to create the code. Lastly, we have polymorphism, which means using the same method for different tasks. In Java, we can use the same object or variable in 2 different places where their tasks will differ.
In this video, we'll be telling you how you can install Java and showing you a very simple Java program. So let's get started. So first off, let's go to Google and search for Java. Here, let's go to this link. And here you have a number of different options. Now, first off, we have Java SE 13.01, which is the latest release. But we are going to go for Java SE 8, which is the more commonly used one, which is used by most people around the world. So this is what we are going to use. So we select this, and here we go down a bit. So to proceed, we need to accept the license agreement. We've accepted the license, so now we can download the software. So we have 2 options to choose from: Windows x64 or x86. Now, if you have a Windows 10 operating system, it's highly likely that you have a 64-bit operating system. So you can select this option. Now, if you do have a 32-bit operating system, which is probably like Windows 7, you can select the x86 option as well. So now let's click on this. So you need to log in and all that. We've already finished and we have the download already. So let's get it. So now this dialog box will pop up. Now we'll go to the next option here. We'll accept them the way they are. And now we'll wait for it to install. So now we need to select the destination where you want the install to happen. So now this is installed in the program files. We select this. If you want to change it, you can go to this option here. We don't want to change it. We'll just go from here to next. And now we wait for the installation to complete. So now the installation is complete. Now we don't need to look at any other next steps. We'll just stop and go to close. So now we need to provide an environment variable. So what is that used for? Now, if you have files or applications that have the .java extension, these help tell the computer that we need to run it using the Java program. So now let's create an environment variable. Go to Start, go to Control Panel, and then we go to System, and then this pops up. Now, before we select the environment variables, we need to find the path where we install Java. So I installed it in C drive here. So let's go there in C Program Files, Java. And here we have JDK and JRE. First, we select the JDK or the Java Development Kit. We select it and go into bin where all these files are present and where the Java file is present as well. So now we're going to copy this path. Now let's go back to environment variables and select path from here, which is right here. Now at the end of this, we'll add a semicolon and paste the path. Now similarly, we'll do the same thing for JRE. So now we're going to do the same thing with JRE here, which is the Java run environment. So we'll go back, select JRE, go into bin and select the path from here. We add another semicolon and paste the path. We press OK and it's done. Press OK here as well. And now we're done. Now to check whether Java has been installed in your system, we need to go to the command prompt. Here we'll type the term javac, which refers to the Java compiler. Now the output will show a number of different options you can choose from. This is an indication that Java has been successfully installed in your system. If the installation wasn't successful, the statement like javac is not recognized as an internal or external command, operable program or batch file will be shown to you. So now that we've set up an environment of Java in our computer, let's see how we can code Java. For this, we'll need to use an IDE on which we can run the Java code. We will be using Eclipse IDE. Now there are several other IDEs like IntelliJ, NetBeans, Dr. Java and so on. First off, we'll need to install Eclipse. So let's go to Google and search for Eclipse IDE. Go here, download, select this option, and now we'll just click on download. So I've already downloaded the exe file, so let's just go there. So then this shows up. So here you have a number of different options. Eclipse can be used for a number of different languages like Enterprise Java, C, C++, JavaScript, PHP, and so on. So we need it for Java developers. So we click this. So this has already determined where exactly the Java file is, which you can see here. It shows in the installation folder here. And now all we need to do is install. We need to accept the terms and conditions, which we'll just go through quickly. Accept now, and now the installation has started. We remember accepted licenses, accept it. This shows up. You can select remember accepted certificates, select these, accept selected, and there you go, the installation is complete. Now let's select launch. Now we need to set up the Eclipse IDE's workspace, which you can change if you want. I'm just going to keep it at this. Now we select launch, and here you go, here's the Eclipse IDE. Now let's have a look at how we can create a very simple Java program. So first we'll close the welcome tab. And here we have the package explorer. Now in case the package explorer isn't shown for you initially, you can go to Windows, you can go to show view and select on package explorer. So now let's have a look at how we can create the program. First we go to file, click on new and select Java project. So here you need to input the project's name. I'm calling it proj1. Press next. And here you see the src file or the source file where all the source code is located. We press finish and it's done. If you click on this, you can also see the source file. Now we need to click on source, right click, press new and create a new class. Here you need to name your class. I'm calling it my class and finish. Now within this we need to create the main function, which is public static void main. Here we'll write a simple statement. And now let's see if the program runs. Now we'll select the class on the basis of which we'll be running the code, and there you go, we have an output. So this is the continuation of the statement in 726. For this video, we'll be using Eclipse as well as IntelliJ, as these are one of the most common and popular IDEs. There are also other IDEs available like NetBeans, Dr. Java, BlueJ, and so on. Now continue to this part, the one on screen. So now that we're done with this, let's have a look at how we can run a similarly simple program on IntelliJ, which is another IDE. Now we'll need to install it as well. So let's go to Google and search for IntelliJ. Let's go here, click on download. And here you have two options, which is the ultimate and the community. Now the community version is free but has limitations, as you can see here. There are certain limitations for the open source version. However, we're going to take this free version and download it. Now I've already downloaded it, so we'll cancel this and I'm going to run this one. We'll go to next, select this location. You can change it if you want by going to browse here, go next. If you want, you can select any of these options. I'm going to select these associations because this basically means IntelliJ also supports these particular extensions. We select the desktop shortcut, go to next and install. Now we'll be running IntelliJ. We'll not send usage statistics. There you go. The IDE is now open. Now we'll click on create new project. We select Java. Now from here you can also select two of your additional frameworks if you want. Here you should also make sure that this option is selected. We have Java SE 1.8. Now if this isn't selected, you can drop down and select this option here. You can press next now. You need to make sure this box is checked. And now we're going to create a command line application. And we are going to create a command line application. Let's press next. You need to select a project name, project 1, and finish. So now we're going to create a very simple program, how you can add two numbers. So let's get started. So now we're going to initialize the first variable, assign it with the value of 10. Then for the second one, assign it with the value of 20. Now we're going to write the code to add the two numbers, sum equal to first plus second. Now that we're done with that, let's print the output. And there we go, we're done. Now let's run this code. And there we go, the program is running successfully. So this is how you code Java in Eclipse and IntelliJ.
In this video, we are going to talk about what is Java, what is Java Development Kit or JDK, the components of JDK, how do JRE, JVM and JDK work together, then the latest version of JDK. We'll also see what Java Lambda expression means and the key features of JDK 9. So what is Java? It is a fast, reliable and secure programming language that can be used in several websites and applications. It can be used to create applications in a single computer or one that could be distributed across several servers and clients. Java can be used in several scenarios, independent of the system that it is used on. So let's look into what Java Development Kit means. All the Java applications and applets are developed using the Java Development Kit, that is JDK. Now, the JDK consists of the Java runtime environment, an interpreter, a compiler, an archiver, and a document generator, and a few more tools that go into developing a Java program. So now, let us have a look at the components of JDK. Java Runtime Environment, JRE, primarily is a part of JDK, and it can also be termed as Java RTE. The JDK provides the minimal amount of requirements needed to write and compile a Java program. JRE consists of the JVM, supporting files, and the core classes. The JVM is key to both JDK and the JRE because it is embedded into them. Now, whichever Java program is being run, the JVM is that component of Java that executes a program line by line, thus giving itself the work of an interpreter. We are now in a position to deep dive into the process with which JDK, JRE, and JVM work. Let's take a source file and save it with the extension .java. This file is compiled and converted into a set of bytecode which changes the file extension into .class. This is done specifically by the JDK. Now, here are the steps that follow. Class loader. It makes sure that all the necessary classes are loaded in the time of the execution of a program. Next, bytecode verifier, that is JVM. The bytecode verifier checks the code for errors or irregularities based on access rights on objects or implementation of pointers. It makes sure that the code fulfills the specifications of JVM and does not break the system integrity. And finally, interpreter, which is JVM. Now, while running the program, the interpreter loads, checks, and runs the code. The implementation is made by the JRE, which is the final process. The latest release is JDK 9 and it was released in October 2017. But it was in JDK 8 that a new feature called the Java Lambda expression was introduced that changed the face of Java. Now, Java Lambda expression is a kind of function which does not need any class to be created. It has been included in the latest version of JDK as it provides a clear, concise way to pass functions around. This also replaces earlier bulky anonymous classes and reduces code verbosity, that is, the length of the code. The syntax for the Lambda expression is this: argument list, arrow token, body. Now the syntax consists of three components, which are argument list. This can be empty or non-empty. Next, the arrow token. Now this is used to link argument to body. And finally, body. This contains the statement that works with the function. Let us now just see an example of using Lambda expression and contrasting it with how code would have been written with anonymous classes. This is the old method, and this is the new method with Lambda expression. Just have a look at how Lambda expression syntax has been used over here. The JDK 9 has been released recently and it seems promising with respect to new features and abilities. Here are some of the features. The first one is Java Platform Module System. This module allows strong encapsulation and declare explicit dependencies. Next, JShell. With the help of JShell, one can directly start writing the code on the console and execute them. Improved Java Doc. Java docs have got the search right in the API documentation, and as an added bonus, the output is also compliant to HTML5. Next, Stream API. The Stream API, also introduced in Java 8, allows programmers to easily parallelize code for improved concurrency and introduces functional programming abilities to the language. The Stream API, in conjunction with Lambda expressions, also comes in handy while iterating, filtering, and extracting large amount of data. The release of multi-jar makes it possible for codes to be run on the newer versions of JDK to be released.
Welcome to this video on how to install Eclipse IDE on your Windows 10 operating system. Now, an IDE is an integrated development environment. On this, computer programmers can perform software development. Now, Eclipse is one of several in the market like IntelliJ, BlueJ, Dr. Java, and so on. Now, to install Eclipse, first you need to install Java. This is because if you try to run the Eclipse installer, this shows up. This shows that you do need Java before you can install Eclipse on your operating system. So first let's go and download Java. Now let's search for Java install and then go to this link. Now here we have the latest version, which is version 13. We're not going to pick that one up. We're going to go to version 8. Now we're choosing version 8 because this is one of the most commonly used versions of Java. So let's select this. So we'll go down all the way here, and here we can see two options, the 64-bit and the 86-bit. So this basically represents the 32-bit operating system. So if you do have one, you can select this option. Since we have a 64-bit operating system, I'm going to select this. But before the installation, you need to accept license agreement and select this. Now I've already logged in, so I'm just going to install now. Let's select this, go to downloads, click on this. And then this shows up. We'll go to next, and let the install complete. So here we have another pop-up. So if you want to change the destination folder, you can select this option. This is fine with me, so I'm going to go with next. That's it. We'll let the installation complete now. So there you go, the installation is now complete. So if you want to look at tutorials or documentation, you can go to the next steps. I don't want to, so let's close and go back. Now just because we've installed Java, we can't exactly run it yet. For that, we need environment variables. Now, environment variables help the computer understand that it needs to run Java when it sees a .java file. For that, let's go to the control panel. Let's go to system, and then let's go here and select advanced system settings. And then this shows up. Now before we can set the environment variables, we'll need the path to where Java is installed. So let's go to File Explorer. Let's click C drive. Let's go to Program Files. So this is where I install Java. Let's go to Java. First, let's go to JDK and bin. Now let's go back here. Click on environment variables. Select a path here. Now go back. Let's copy that and press on new and paste this. Now likewise, let's go back, go to JRE, which is the Java runtime environment, and JDK, which is the Java development kit. Click on this, go to bin, and select this path. Go back, go to path, select new, and paste this as well. And there you go, the environment variables are now set. Let's click on OK, and that's done. Now let's install Eclipse. Let's go back again and search for Eclipse. In here, select this option, click on download, select 64-bit. So and this shows up. So I've already downloaded it, so we can directly go there. I'm going to click on this now. So now we have the installer show up. So here you can choose from a number of different options like C, C++, PHP, and so on. So you want this one, we'll click on this, and here we can just install. We'll accept, and there you go, the installation is going on right now. We'll remember accepted licenses, accept this. You need to accept these certificates, accept selected. And there you go, we're complete. Let's launch. So now we need to set up a directory. So I'm okay with this. So let's launch. And there you go. Here's the workspace. So let's run a very simple program now. So we'll close this. And here you have the package explorer. Let's open this up. So in case you can't access the package explorer, go to window, click on show view and select package explorer. Now first, to run a program, you need to create a Java project. Click on this and let's name our project. Let's go to next. And here you see src or source. Now this is where the source code of your program is. Now we'll just finish, and that's that. Now we go to source, right click, new, and create class. Now let's create a class 1 and finish. And now we should be able to run any program we want. Let's look at the very simple code of writing hello world. So let's open the main function. There we go. Let's open a bracket. Here, let's print. And that's that. Now let's run the program by clicking on this icon. Let's select the class, and there we go, we have an output. This means the program is running successfully.
Let's begin with the fundamentals. So the first one in the fundamentals is the data types. So every programming language has a data type. So what exactly is a data type? So whatever the input you provide in your program is a data type. For example, if you provide numbers, so in that particular numbers, we have a different variety of numbers. If you are giving just 1, 2, 3, so on without a decimal number, then that particular type of input, which is a number, will be considered as integer type. If you provide the same number with a decimal point, then that will be considered as float. And if you have the range greater than float, it will be considered as double, and so on. So this is how we have multiple data types in every programming language. So the most frequently used data types in Java programming languages are as follows. At first we have the byte, followed by that we have short, int, long, next float, then double, boolean, and finally char. Apart from this, we also have few other data types, but these are the most frequently used ones for all the basic programmings. So this is made for beginners basically. So you can take a quick screenshot of this particular slide so that you can have a quick overview or reference to all the data types in Java programming language. So I hope you have taken a screenshot of this. Now let's begin with the next concept. So in the next concept, we have the keywords and variables. So all the programming languages have variables and keywords. So variables are used to store the values. So for example, consider that you wanted to run some arithmetic operation on two different values, that is 5 and 10. So in order to do so, you might want to create a variable which stores them. For example, you wanted to store the value of 10 in a certain variable A and the 5 in a certain variable B. So if you apply the arithmetic operation, that is A is equals to A plus B, then the value of A, which was previously 10, will be updated to 15. So here you can see the value is varying, and also it is storing the result. So this is why the variables are used in a program, in order to store a value, and this particular term variable is used because the value can change at any instance of time once after a certain arithmetic or a logical operation is performed on that particular variable. So similarly, we have keywords. Unlike variables, keywords have a special meaning. No matter whatever you try, you cannot change the meaning of that keyword. For example, consider main. So you cannot use the term main for normal things because the part or the term main is dedicated for a different purpose. So whenever you try to execute your Java program, the control flow will start executing the program right when it reaches the term main. So it has a special meaning. Similarly, you have other keywords such as int, so that is dedicated for integer type of values, and float for float type of values, that is a decimal values, and byte for byte, char for character type data, string for string. So every keyword or every term with special meaning which is predefined and cannot be changed is called as a keyword. Now let's see the most frequently used keywords in Java programming language. So similar to the previous one, we have a table here. So in this particular table, we have the most frequently used keywords in Java. So you can see we have boolean, final, byte, native, and we have void, switch. So switch is a conditional statement. So we have if it is also a conditional statement. We will go through these conditional statements as we proceed in our tutorial. And you can also see the protected. So this term, which is protected, public, so this is basically the access modifier. Even this particular keyword have special meaning. This public, this protected keywords provide the information to the compiler or the interpreter about the accessibility of that particular data member or data manipulating method. So if it is protected from your accessibility or is it available for you, it's provided by these keywords. So we will deal with access modifiers in the upcoming parts, don't worry about that. And as you can see, we have implements, extends. So extends, this term comes in inheritance. So inheritance is one of the crucial concepts of object-oriented programming. You can also see abstraction. So this we will be dealing in the next upcoming part, where we will understand the object-oriented programming concepts. Next we have interface, return, and so on. You can also see some keywords like throw. So throw will come in exception handling. So we will also learn about exception handling in the upcoming part. So these are the most frequently used keywords in Java. So now we will move ahead into our next concept. So the next concept is the operators in Java. So to understand operators, let's go through a table. So on my screen you can see a table which has some arithmetic operators which are most commonly used. That is the plus for addition, minus for subtraction. Similarly, we have star, /, double plus, double minus. So double plus and double minus, say they are increment and decrement operators respectively. As you can see, we have a plus plus here, which means the post increment. So the first value will be read, after that the value will be updated. Next we have the pre-increment, the value will be incremented first, then the updated value will be stored. So that's how the increment and decrement operators work. So we have the modulus over here. So to understand the operators that we use in Java in a much better way, let's try to execute a sample program. So on my screen you can see a program which is based on operators. So we are currently on the Eclipse IDE. Don't worry about the IDEs in Java, etc., etc. So I will drop a link in the description box below, which will explain you in a very detailed way about how to install Java into your local system, and how to install Eclipse IDE in your local system, and also how to create your first project, how to create your package, how to create a new class, how to write your program and how to run that, how to see the output, and a complete overview of the Eclipse IDE, how that works. So everything will be linked in the description box below. You don't have to worry about that. So right now, to save time, I have created the text document which has all the programs that we will be executing today. So I will also drop a link for that particular file so that you can have complete access to that file, so that you can run the programs in your personal PCs or laptops and also understand the programs in a much better way. So now let's begin with the program. So this particular program is basically designed for arithmetic operations. So you can see we have the operators, that is the addition, subtraction, multiplication, division, modulus, and exit. So basically we will be taking input from you. So the input will be taken by the user. That is, we are using scanner class here. So scanner class takes the input from user, and that particular input will be compared here. So we are using the switch case here. So if you provide the option as 1, then addition operation will be run. Similarly, second for subtraction, third for multiplication, fourth for division, fifth for modulus, and sixth to exit. So this is how the loop or the program works for arithmetic operations. Now let's quickly run this program and see the output. So you can see the program got successfully executed, and we have the console asking for the first input. Let's provide some random number. Now let's provide the second number. So there you go, we have our options over here. Now let's choose division operation. For that you need to provide the number 4. So there you go, we have the result over here, which is 4. Now the loop has started once again. Now it's in the starting stage again. It's asking for numbers. Now let's provide a 25 and 5. Now let's choose some operation, that is addition. So for that you need to provide 1. So we have the result again, that is 30. Now let's again choose some number, 10, 5. So basically that's how the program works. So we have the brief idea how the program is running now. So now let's quickly continue with our next topic. Now to terminate this loop, you can provide the option number 6. So we have terminated it. So I hope you understood how the program flow is running. So if you did not understand, don't worry, I have linked the document in the description box below. You can take the access of that particular document and you can check the program and run in your local system, and also you can make some modifications to it. As you can see, we don't have a default case over here. I've just placed the case 1 to 6, and I'm saying the default because you can see that the options are from 1 to 6. What if the user provides the number as 7? Right? So the program might crash over here. So for that purpose, you can write in another case that would be the default case. So the default case will check if the number is anything above or out of the range of 1 to 6, then it should be providing you with an output saying a wrong input has been given, or check your input, or something similar. So that's how you can make some modifications to it. You're free to modify the code as well. Don't worry about that. So now let's quickly begin with our next concept. So in the next concept, we have the conditional statements. So what are the conditional statements or the control statements? So basically these are these are conditions. So what happens is, just imagine that you wanted to do something, or if you wanted to drive a vehicle, or if you wanted to drive a bike. So the condition you will apply on your mind is, if I know driving, then I will do it. If not, I'll not do it. So that's what you do, right? So basically you apply a condition on your mind and you do it if it is capable of doing, or if you are capable of doing it. So in the same way, the conditional statements play a major role in computer logic. So before writing a code or before you start your program, you provide the condition. Perform this particular operation if the provided condition is satisfied. So similarly, you have these three conditional statements in Java, which are if else, and nested if. So we use these conditional statements in Java to implement our logic. So we will understand the conditional statements, particularly if else, and nested if, in a much more detailed way by practically running some programs based on these three types of conditional statements. So now you can see that we are back on the Eclipse right now. So this particular code segment is based on the if condition. I hope the program is visible. Let's try to increase the font size. So I think it's better now. So basically we have an input. So we have the integer type of input, that is num, and we have the number as -100. So it is a negative number. And after that we have the if condition. So this is where the conditional statement is provided. So the condition is, if the number is greater than 0, if the provided number is greater than 0, then the control should enter the loop, which is this particular segment, and execute the statements present inside that particular loop. So here we have one single statement, that is a print statement, that says the number is positive. In case the condition fails, imagine that the condition fails, then what happens is that instead of entering this particular code segment, the control will skip and execute the next statement, that is another printf statement which we have over here, which says the if condition is terminated, control is outside the condition block. Now since we have provided a negative number, the second option should go ahead. Now let's try to run this and see the output. So there you go. As expected, the program got executed and we have only one statement, that is if condition is terminated, control is outside the block. Now let's try it otherwise. Let's just eliminate the negative number and now check it again. There you go. Now you can see the program got executed and now we have two print statements. You can see that the condition here was true, so the control entered into the statement or the code block, and this particular statement got executed successfully. Once the statements are executed and there is nothing else to do, then the control will automatically exit this particular statement and it will enter into the next statement, which is another printf statement, and we have the same output over there. So this is how the single if statement works. So you can also modify this with an else. So that's the next program that we are going to see. We are going to execute some similar kind of example for our next kind of conditional statement, that is if else. So here only we had one if condition. So in case if this particular condition fails, then we will be having another condition over here, which will be the else block. So as you can see, we have another program. So this particular program is based on if else condition. So here you can see that we have our first if condition, which states number should be greater than or equals to 0. If this particular condition is true, then this statement should be executed, which says the number is positive. Else, if this condition fails, then what you must do? The control should avoid entering this particular segment and it should directly hit the next segment where we have the else block, which has another statement which says the number is negative. So this is how the program works. So here we will be doing a little modification over there. Instead of taking an input which is previously defined as it was in the previous example where we had given -100 previously, we are going to do it a little differently. This time we'll be taking or reading the input directly from the user. So for that we are going to use this scanner class. So this is the particular library that we will be using. So we have imported java.util.scanner. So this particular code segment will ask you for the input and you will press some random number and it will read it as its input. Now let's try to quickly run this program and see the output. There you go. The program got successfully executed and now it is asking for an input from the user. Now let's try to provide a negative number. So there you go, the program got successfully executed, and you can see that since we had given a negative number, the control did not enter this particular code segment at all. It directly avoided to enter this code segment and entered into the else block and executed the statements present in that particular else block, which was a simple print statement that had the statement which read as the number is negative. Now let's try to execute the same program again and see what would be the output. So there you go. Now it's asking for the input again. Now this time let's provide a positive number. So there you go. Since we provided the number as a positive number, this condition was true and this particular statement got executed. Since one of the statements executed, there was no need for the else block to be executed again. So you can see this particular code segment runs in this way. So once the condition is checked, so if the condition is true, then the true statement will be executed. In case if the condition's result is false, then the false statements will be executed. So you will be provided with two options. So one option for true validity and another option for false validity. So this is how the if-else block works. I hope you understood this. Now with this, let's continue with the next type of conditional statement, that is the else if ladder. So on my screen you can see there is a change of program. We have stepped into the next type of conditional statement, that is the else if ladder. So basically everything will be same. We will be provided with only one condition. So we will be checking the validity of that particular condition. So if the provided condition is true, then the first one will be executed. If it is not, then the second one will be executed. If the condition fails for the first two, the third one will be executed. If the first three fail, then the fourth. And if all the four fails, then we will have one last else which will print the last segment or statement. So this is how the else if ladder works. So basically it's completely similar to if else, but the only difference is instead of one else block, we have multiple else blocks. That's the only difference. Now let's quickly execute this program and see the output. So basically we are going to take an input from the user. So we will be entering 1 for noodles, 2 for milkshake, 3 for fruits, 4 for coffee. So something like that. And if we provide anything else than 1, 2, 3, 4, then we will be having an else statement which says it's an invalid input. So the flow of this particular else if statement is similar to the switch statement. Having said that, we will also discuss something about switch statement as well. Basically we'll try to execute a program based on switch statement, and we will also understand the control flow of that. Don't worry about it. Now let's quickly execute this particular program first. So there you go, the program got successfully executed. Now it's asking for an input. Let's select noodles. That's how it works. We have the output noodles. So the choice is equals to 1. So the first one was true. So it executed the first code segment, and everything else got suspended because this was not necessary to be executed because the condition was true over here, and according to that only this particular statement was supposed to be executed. So that's how it works. Now let's switch into the next conditional statement, which is the switch. So you can see that we have a program on my screen which is based on switch case. So you can see that there is some similarity between this particular program and the first program we dealt with, that is based on operators. So we also have the default code segment over here. So this was what I was talking about. You can add a default code segment in that particular program, which is the operators program, and do some modifications. So this is what the suggestion I gave over there. Now basically what happens in this particular code segment is, so we have Monday as the day 1 of a week, Tuesday as the day 2 of the week, and so on. So to select one particular day of a week, you need to provide an input. So it's based on 1, 2, 3, 4 and so on to 7. And if you provide anything else than 1 to 7, you will be provided with a message which says invalid input. So now let's try to run this program and see the output. So there you go, the program got successfully executed. Now let's select the weekend day. So which would be something between 6 and 7. So 6 is Saturday and 7 is Sunday. Let's go with 7. So there you go, Sunday. Now let's try to execute this program once again and give a wrong input and see if it works or not. Let's provide 8. There you go. The program identified it as a wrong input, so it gave us a message invalid input. So that's the use of default code segment in switch case. So you can implement this in that operators program and check out how it works. Can be considered as a homework though, not a problem. Now this is how the switch case works. So with this, let's move ahead into the next concept in our Java tutorial for today. So the next segment is about the loops. So what are loops? So conditional statements are some statements which get executed based on a condition if the condition is true. If not, then that particular condition will not be executed. Loops are a little different from conditional statements. How? So basically you will be provided with one single statement and you wanted to execute that one single statement for a particular number of times. So in that condition, instead of writing the same code segment for several number of times, you can just use a loop. For example, consider that you wanted to print numbers from 1 to 10. So the brute force method or the simple or the first method that fires to your mind is write that print statement for 10 times. That is print 1, print 2, print 3 and so on to print 10. But what if you had to print 100 numbers? Okay. Doable. You can write the same print statement for 100 times. But what if you had to print 1000 numbers? Imagine 1 billion. Can you do 1 billion print statements? No, right? So in that scenario, you can use loops. So you can just write one condition. Repeat this particular print statement for 1 billion times. Then the interpreter or the compiler will take care of that. So that's the reason why we use loops in Java. So basically we have 3 loops in every programming language. That is the for loop, while loop and do while loop. So a loop statement in Java execute a set of statements until a specific condition is satisfied. So here the 1 billion example. So here you will start from the 0th count. So that will be the counter variable which counts the number of repetitions, and followed by the counter variable you will be having the condition. So you will be having the counter variable I is less than or equal to the number 1 billion. So until that you have to print this particular statement, and followed by that you will be having the increment or decrement operator. In this case you need to use the increment operator. For the first time, once the print is done, you will increment the value to 2. And the loop will be iterated once again. So this will continue. The loop will iterate itself until 1, 2, 3, 4, so on, and until it reaches 1 billionth number. So that's when the condition fails. I is greater than or equal to 1 billion. So that's when the condition fails. The condition was to be I should be less than or equal to 1 billionth. So when the number increments above 1 billion, then the condition fails. So the condition was the number should be less than or equal to billion, but the number has exceeded the billion. So that's when the loop terminates and executes the next statement after the loop. So I think this was a little clear about the loop workflow. Now to understand the loops in a much more better way, let's execute an example for each one of these types of loops. So we have for loop, while loop and do while loop. Let's execute the programs for all of these 3. So you can see that we have a program on my screen. So this particular program is based on for loop. So you can see that the code part highlighted on my editor is the for loop. So you can see int I is equals to 1. So this is the counter variable. So I is the counter variable which stores a number from where the count should begin. So sometimes you can choose 0, sometimes 1, or the number of your choice. So here I've chosen the number 1. So after the initialization part, we have the condition part. So remember the 1 billionth example we discussed before? So here we have I should be less than or equal to 10. So this particular loop segment will run until the condition, that is I value should be less than or equal to 10, is satisfied. Once it turns false, the control will exit the for loop. So that's how it's designed to work with. Now followed by the condition we have the pre-increment operator. Once the condition is checked, the control will jump to the next statement, that is the pre-increment operator, and it increments the value of 1 to 2. So this is how the loop works. Now let's try to execute this program and see the output. There you go. The program got successfully executed and the output has been printed. So basically, what was this statement to be executed? It was a printf statement looped plus. Here the plus symbol works as a concatenation operator. Here too. Now in between the printf statements we have the value of I. So in the first place I was equals to 1. Once the pre-increment was taken place, the value of I will be increased to 2. So there you go, you can see the number 2 over there. Now in the second iteration we print the value looped 2 times. Similarly in the third iteration looped 3 times. So that's how it works until the last iteration, that is looped 10 times. So once the condition is checked here, the control will enter into the next part where the pre-increment takes place. So the pre-increment increments the value of 10 to 11. Now the control will come back to the initialization part. Here we have the new value for I, that is 11. Now 11 will be checked against the condition. Is 11 less than or equal to 10? No, right? So the condition here fails. Now the loop is terminated. The control will exit the loop. So this is how the for loop works. Now let us also consider another example for for loop for a better understanding. So in this particular program we are going to print the sum of n numbers. So in that particular n numbers, we will be having even numbers and odd numbers. For example, consider that you have provided the number as 5. So the numbers in between 0 to 5 or 1 to 5 are 1, 2, 3, 4 and 5. So the 4 is even number, and apart from 4, everything else are odd numbers. So odd numbers are the numbers which are divisible by 1 or itself. So now the sum of odd numbers is 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 5 is 11. So that's how you print the sum of odd numbers, and the sum of even numbers, that is only 4. So that's how the loop works here. You have the condition, if else condition, and out of that if else condition you have the for loop. So this particular loop should be running until a given number that will be given by you. So that's how the program works. Now let's quickly execute this program and see the output. So there you go, the program got successfully executed and now it's asking for an input. Let's check out 5 itself. Now you can see we have another program on my screen which is basically based on the same for loop. So here we have the for loop. We will be providing an input which is num, and inside that we have another condition, that is the if else loop. So basically if loop is dedicated to find out the even numbers and else loop is dedicated to find out the odd numbers. Now the whole motto of this particular program is to find the sum of even numbers and the sum of odd numbers between 0 to the input number which you provide. For example, consider if we provide the number 5 as the input, then in between 0 to 5 we have odd numbers and even numbers. So the even numbers are 2 and 4 and the odd numbers are 1, 3 and 5. So basically what happens here is we are going to add up the numbers. So the sum of even numbers, that is 2 and 4 is 6, and sum of odd numbers, that is 5 plus 3 is 8, 8 plus 1 is 9. So that's how it should work. Now let's quickly try to execute this program and see the output. So you can see the program got successfully executed and now it's asking for an input. Now let's enter 5 itself and see the output. So there you go, the sum of even numbers up to 5 is 6 and the sum of odd numbers up to 5 is 9. So this is how the program works. Now apart from for loop, we also have another way to declare the same for loop. So that particular type of for loop is called as the enhanced for loop, or in some cases it's also called as advanced for loop. Let's see how the for loop is declared in a different way. So instead of using the typical for loop which has the initialization state, then the condition, then the pre-increment or post-increment or decrement kind of operations, we simply have declared the for, and inside that we have int arr, which is the name of the variable of array type, and inside that we have the array. So our array consists of 10 numbers followed from 1 to 10, and now this particular loop will execute for 10 times or until all the values in the array are printed. So now let's try to print this. So there you go, the program got successfully executed and we have all our values from 1 to 10 which were the input or the saved part of the array. Now with this, let's continue with the next kind of loop, that happens to be the while loop. So you can see an example based on while loop on my screen. So basically everything is same. There is no much of a difference between for loop and while loop, but the only difference is the keyword. Instead of for, we have a while over here. So we have the while condition over here, which says I should be less than or equal to num divided by 2. And if this condition is true, then the control should enter into the conditional statement if num modulus I is equals to 0, flag is equals to true, and break. So basically the whole motto of this program is to find out if the given particular number is a prime number or not. Now let's quickly try to run this program and see the output. Now you can see the program got successfully executed. Let us try to provide a prime number and see if the program could identify it correctly as a prime number or not. There you go. The prime number we provided was 5 and the program successfully identified it as a prime number. So that's how the while loop works. Now let's execute another program based on while loop, but this time we will place the condition at the end of the loop. So yeah, you guessed it right, this is do while loop. The only difference between while loop and do while loop is that before the condition is checked in while loop, no statement is executed. But it's completely opposite when it comes to do while loop. First, the program or the code segment will be completely executed. After that, the condition will be checked. Surprising, right? Let's check out the practical part. Yeah, we have our program on my screen right now. So in the previous program, we had the condition somewhere over here. That's the while condition. But here we have the do statement here. So what we are going to do is we are conveying the compiler or the interpreter to execute this particular statement first without checking the while condition. So this is the only difference between while loop and do while loop. So we have run the program successfully and it got executed, and we were supposed to actually print the values of I from 1 to 20, and they have printed over here. That's how it works. Simple, right? Now with this, let's continue with our next topic. So basically the next topic is the next segment in our tutorial, that happens to be the object-oriented programming in Java. So before we begin with the object-oriented programming concepts, the first major things that we need to learn are the classes and objects. So the whole object-oriented programming concept revolves around these two basic fundamentals, which are the classes and objects.
Welcome to this tutorial on objects and classes in Java. This is a part of our Java tutorial series where we will be covering everything you need to know to master Java. Let us look at what we will cover today. First, we will talk about objects and we will implement two programs on IntelliJ to learn about objects. Then we will move on to classes in Java where we will see an advanced program to learn classes more in depth. So what are objects? An object is an instance of a class. Let's have a look at an example. In this example, animal is a class and dog is its object. The object dog has states and behaviors. We can have dogs with different breeds, sizes and colors. These are considered as the states of object dog. On behavior side, dog has behavior like barking, eating and wagging tail. So an object has its own states and behaviors. Now let's look at an example using Java code. There are many platforms to run Java program. So for this video, I'll be using IntelliJ. So let's create a new project. Let's name it as project 1 and finish. There we go. We have a new project. We have a class with main and we have a main function. So the code that we write should always be written in the main function. So let's create a new class to understand how the object is used. Let's name it as student. We need variables so that we can access the variables of this class. So I'm going to use student ID with the integer type, student name and student's age. There we go. Now we have these three variables that we can use. So let's go to our main program and start our coding. So we have a class named student. Now let's see how to create an object of a class. This is the syntax to create an object. Now the object here is S. I created an object S of class student. Now let's assign values to the variables. For this, we use the object S and use the dot operator, and we have options from which we can choose from that we declared in the class student. So for this, I'll use ID and give a value. Similarly, I'll give age and give a value. And finally, let's give a name. Now we'll print its value. Now we are going to run this program. Let's see what output we'll get. And there it is. We have name, that's Simplilearn, we have age, and we have ID. Now let us see an example how we can use multiple objects for a single class. So let's get started. Let's create a new project and I'm going to name it as vehicles. Because I'm going to use cars and bikes in this program, so I'm going to use vehicles as a combined form. And yes, here we have a class main and a function main. Now I need two classes for this program. So I'm going to create two classes. First I'm going to name it as bikes, and the second class I'm going to name it as cars. So let's create variables for these classes. So in cars, first I need string, name, and I need the cost of the car. So cost can be integer as well, because I'm going to use $sign in that. So I'm going to use string because of that. So same thing I'm going to do with bikes. Now that our classes are created, let's create objects for this class. So the process is same, but we are going to use different names for the object. First, the car class, and I'm going to name as car1. And yes, we have created the first object. Now to create the second object, similarly, I'm going to create 5 objects of the class cars. And I'm going to change the name for them. So I created 5 objects of the same class. So I'm going to create 5 objects of the bikes class as well. So bike one will be a bit longer. So I'm going to use B1 till B5. And I'm going to name them from B1 to B5. So now I'm going to assign values to the variables that I created in classes bike and cars. So first I'm going to go with cars and let's name it as Lamborghini. Similarly, car2, Ferrari. So I'm going to use names of the cars that are very famous and costly so that anyone over the world can understand this. So let's name car 3. I'm going to name it as Bugatti. Similarly, car 4, Pagani, and car 5. Now I'm going to give names for bikes. I hope everyone will understand the names that I give. B4 and B5, the last one, Yamaha. Now let's assign the cost for bikes and cars as well. So the procedure is same. So let's do it 130,000. Same B2. So B1 goes for Harley Davidson, B2 for Ducati, B3 for Suzuki, B4 for Ecos, and B5 for Yamaha. I am going to assign values for these values accordingly. For Ducati, $232,000. For Suzuki, 200,000. 300,000. And the last one, Yamaha, 500,000. Now similarly, I'm going to assign values for car1.cost till car5.cost. $203,000 for Lambo. I think I can copy paste these as well. So let's copy paste it, a lot faster and easier to do. Car 2, car 3, car 4 and car 5. We don't need this. As per car 2, let's take it as 252,000 and let's make it as 3 million. As per this, let's keep it as 1,400,000 and lastly let's take it as 293. Now that we have assigned all the values for all this, now let's print it and get the value. I'm going to create a very simple program, but a very user-friendly program. So it's going to be interesting for you guys. So we are going to ask the users what would they like, either bikes or cars. So we need to give them the options, and our next program will be based on the options that the users select, not the options we give as the command. So let's do it. Let's give the options 1 bikes and 2 cars. I need to take the value that user gives. For this, I'm going to write this command. So I have not used scanner yet. So let's import scanner. And let's create an object for scanner. And yes, let's get back. So the data type of choice variable is integer. That's why I'm using next int. If the data type was string, then I would have used next line. So now that we have choice from the user, let's use this value. If the user chooses the first value, that means bikes. So the next thing we display is we have models, and we are going to give 5 models for bikes to the user. Here I am giving options to the users so that they can choose easily from number 1 to 5. Now we can show these options to the users so that they can choose from one of these values. So let's use one more if statement so that we can find out whether they have this value or not. Before that, I'm going to ask which one would you like to choose. To enter the choice, I'm going to use one more variable. Let's say n. So I'm going to store n. If n is equal to 1, that means Harley Davidson. Then I'm going to show the cost of Harley Davidson. This is the syntax to print the value for the cost or any of the variable that we use in class. What if the user says second or third or fourth or fifth? So for that, we are going to use else if statements. If n is 2, that means Ducati. So we have to show the rate of Ducati or the cost of Ducati to the user. Now similarly, I'm going to do for n is equal to 3, n is equal to 4, and n is equal to 5. Now I'm going to do for n is equal to 4. And lastly, n is equal to 5. That is our last bike, Yamaha. What if the users put a number that is not between 1 to 5? So for that, I'm going to use else statement and put a message that please enter the value from 1 and 5. So now we have code for the bikes, and the same thing, what if the user selects that he wants to find the car? So for that we have this, the choice is equal to 1. So the same thing we are going to do for choice is equal to 2. And the same thing we are going to tell to user that we have 5 models. The same names that I gave to variables, I'm going to give this to here. Second one Ferrari, third Bugatti, fourth Ecos, and the last one Porsche. Now we are going to ask the users their choice, that which number do they want to choose. Now we need one more value so that we can have it as a variable which can store the choice of the user. So for this I'm going to use C. Now if C is equal to 1, that means if the user wants to see the cost of Lamborghini, that he puts the choice as 1. So we're going to display this message, the cost of Lamborghini. And we are going to use else if loop to enter the next values for C from 1 to 5. If C is equal to 2, that means the user wants to know the rate of Ferrari, then we are going to show the cost of the Ferrari. Same thing if the user enters 3 as the choice. If user enters 4 as the choice, then we go for ECOS. And the last one, if user enters the choice as 5, then we have to display the cost of Porsche. Now what if the user enters none of the values from 1 to 5? Then we have to display a message showing that please enter the value between 1 to 5. Now remember the first choice that we wanted from user to enter either bikes or cars. So what if the user do not enter either 1 or 2? So for that we need one more else function to tell the user that either enter 1 or 2. And with this we have completed our code. So now let's run this program. For this we need to go to run and then run main. There's a shortcut for it, that is shift plus F10. So let's run the program. And yes, we have successfully executed the program. Let's test this program now. So enter your choice. I'm going to enter 1. And yeah, we have 5 models: Harley Davidson, Ducati, Suzuki, Pagani and Yamaha. So enter your choice. I'm going to enter 1. And yeah, we have our result. The cost of Harley Davidson is $130,000. So with this, we have completed our code. And please feel free to type this code in your own computer and try out all the permutation and combinations that you can with this program. So with this, let's move on to classes and understand the classes and their concept. Then we'll have a new program on classes. Now let's see what is a class. A class is a blueprint from which objects are created. A class describes state or behavior of an object. In this example, dog is a class. The variables in this class are breed and color. The functions or methods of the class dog are barking, hungry and sleeping. We use objects of a class to use variables and functions of the class. With this, let's understand classes with a simple Java code. Let's create a new project. Next, tick the box and let's name it as automobiles. Let the base package be student. And yes, we have a class main. Now let's create some classes to do code on. I'll create a new Java class as cars. And then I'll create one more class with the name bikes. And then one more class automobiles. So I'm gonna connect cars and bikes with automobiles so that we can use that program in main and see what can we do with the classes that we create. In automobiles, I need some variables. I'll take private, double and let's say fuel. And then same thing, private, double and then year. And let's take one more, private, string and brand. Now let's have getters and setters for this. So these are used to get the value and set the value for the variables inside the class. There we go. We have the getters and setters for it. Now let's go to class cars. So public class cars extends automobiles. So in it, I'm gonna create one more class or a constructor. And I'm gonna print a message. Say a new car has been created. Car has been created. Now the same thing I'm gonna do with bikes. Let's go to bikes and I'm gonna use the same thing, extends automobiles. This is because I can inherit all the variables from the automobiles class. So I created a constructor and I'm gonna print a message. A new bike has been created. So I have created class, cars, bikes and automobiles. So let's go to main program. So this is where we should write our code. So I'm gonna start with the code now. It's a very simple code. First I'm gonna create the variables or the objects of the class with private bike. So one is car and one is bike, both are objects for the classes. So I'm going to use these objects. Bike is equal to new bike. This is so that my object can function really well, and now I'm going to run it. It will take some time to run. And yes, there we go. Our program has executed, and the things that I typed, a new car has been created, a new bike has been created, are done. Now let's try something else using the classes. So I'm going to bikes. So I'm going to create a new method or a new function, public void kick for bike. So I'm going to print message. The bike has been started with kick. Bike has been started with kick. Now the same thing I'm going to do with cars. Now how does a car start? With the key. So I'm going to make a function public key, and inside it I'm going to print the same message, car has been started with key. Oh, I should write void there to give the return value as void. So let's print the message, car has been started with key rotation. Let's write that as well. So in the main program I'm going to use objects to use those functions, and let's see what changes they'll do to our program. Bike.kick and car.kick. Let's run this. And there we go. First we used to have this two messages, but now these two messages are also there as well, because we invoked those functions and methods that are there in class cars and bikes. So if I write bike.key or car.kick, this won't work. This is because key is not a method of bike or kick is not a method of car. So that's why I gave private static for the functions. So if I execute it, these are the error messages that I'll get. Cannot find the symbol method kick or method key.
What is an abstract class? The answer is, abstraction is one of the keys to achieving an object-oriented programming approach in designing a software. Here, the programmer tries to hide the complicated implementation of the code, which makes the software run smoothly. Most of the time, the user isn't interested to know how the code is being implemented. So, through abstraction, we can just hide it. To do so, we use an abstract class or sometimes an interface based on the requirement. So, abstract class in Java is considered as a template of methods and variables which are used in a program. Remember, abstract classes cannot be instantiated directly. Now moving ahead, we will next learn the important features of abstract classes. So the first one is template. The main reason programmers prefer to use abstract methods is because they act as a predefined template for any future specific class that you might use. Next, loose coupling is a procedure where an internal object gets the necessary method or a different object from the external world, that is, other than the current working project. The use of abstract classes makes this process possible. After that, we have the code reusability. Implementation of the abstract classes provides the developers with one of the greatest features that saves time, which is none other than the code reusability. Followed by code reusability, we have abstraction. As discussed earlier, data abstraction is the process of hiding certain details and showing only essential information to the user. Abstraction can be achieved with either abstract classes or interfaces. Last but not the least, dynamic method resolution. The abstract classes enable us with dynamic method resolution or the dynamic method dispatch process. The dynamic method resolution is a mechanism by which a call to an overridden method is resolved at runtime. This is how Java implements runtime polymorphism. When an overridden method is called by reference, Java determines which version of that method to execute based on the type of object it refers to. Now, these were the few important features of abstract classes. Next in the docket is the crucial rules to be followed to use abstract classes. Alright, let us go through the rules one by one as mentioned below. The first one is the keyword abstract is mandatory to declare an abstract class. Followed by that, the next rule says that abstract classes cannot be instantiated directly. The third one is an abstract class must have at least one abstract method. Next to that, we have another rule which says an abstract class includes final methods. Next, an abstract class may also include non-abstract methods. It's not mandatory that an abstract class should only include abstract methods. So the last rule says that an abstract class can include constructors and static methods. So these were some crucial rules to be followed to use abstract classes in Java. So far, we have discussed the definition of abstract classes, its features, and the rules to use abstract classes in Java. Now, we will learn how to achieve abstraction in Java. So basically, there are two different ways to achieve abstraction in Java. The first way is by using abstract classes, and the next one is by using an interface. Now, this brings us to our next topic, that is the syntax to be followed to use an abstract class and an abstract method. To declare an abstract class, we use the keyword called abstract. Followed by that, we use the keyword called class. Then after that, we declare the name of our class. The name of the class is up to the user's choice. For example, I have named my class as Simplilearn as shown here. Followed by the abstract class, we have the abstract method. To declare an abstract method, we use the keyword called abstract. Then, the return type of the method. As of now, I have used void. Then, later we have the name of the method that is based on the user's choice. As you can see, I have used Simplilearn as the name of the method. So, this was by using abstract class method. The next one is by using an interface method. Now, what exactly is an interface? So, interface can be defined as a boundary between the method and the class implementing it. In Java, we use interface to achieve abstraction. In other words, we can also consider interface as a container which saves the signatures of the methods used in a program. Now we will move ahead and understand the syntax to use an interface to achieve abstraction in Java. To declare an interface, we use the keyword called interface. Followed by that, we declare the name of a class. The class name is up to the user's choice. For example, I have named my class as Simplilearn as shown below. As discussed earlier, interface acts just as a container that stores only the signatures of the method. We cannot have a complete method defined inside it. All we can do is just declare an interface. Now that we have a detailed explanation about the abstract class and the interface, let us look into some example programs based on abstract classes. Now we have successfully booted the Eclipse IDE. Now let's create a new project. So to create a new project, just click on Create a Project. And this should give you a dialog box wherein you have to select Java Project. Click Next. Now let us give a name to our project. So Simplilearn will be the name of my project here. Now let me click on Finish to finish this process. As you can see, the project has been successfully created. And inside the project Simplilearn, we have the source file, and right-clicking the source file will give us a drop box where you can just select new, and inside new you can select a new package. Now let's name the package as Abstraction and click on Finish to create the package. Moving further, let's right-click on the package and select New, and from New, select a class to create a new class. So the name of my class will be Employee. Let's click on Finish to create the class. Now we have our Employee class ready. Now let's right-click on the package and select New, and inside that, let us select another class. And the name of this particular class will be Person, which will act as our abstract class. So as you can see, we have declared this particular class with the keyword abstract, and the name of the class is Person. So our first example, which is based on employees, where we will have an abstract class called Person, and this Person class will be inherited by the employee class and gets executed to generate employee details. Now let us try to execute this program and see the output. To execute the program, just right-click on the package and go to the Run option and select the first one, that is Java Application. Now you can see we have the employee named Pavitra and the gender is female, and the employee has logged in successfully. So these are the details which we were expecting to be presented on the output console. Now moving ahead, we shall execute our next example, which will be based on students. So here the class student is the abstract class, and three different student classes, namely Raju, Pranita and Punit, will inherit the student class and generate the output that displays their particular ranks. So you can see our abstract class, that is student, is being declared using the keyword abstract, and inside that we have an abstract method which is getRank. And these classes, that are Raju, Pranita and Punit, will inherit the abstract class student and display their ranks. Now let us try to execute this program and see the output. As you can see, the three classes have successfully inherited the abstract class and displayed their ranks on the output console. Now let us move ahead and try to execute one last example based on abstract classes. So the third and last example is based on interest rates provided by different banks. Here we have an abstract class named Loan, and all the banks described in the program will inherit the loan abstract class to calculate the rate of interest on the loans provided by them. As you can see, we have the abstract class, that is loan, and inside that we have the abstract method, which is interest. So we have the classes Andhra Bank, Bank of Baroda, JDBC Bank, State Bank of India, which are inheriting the abstract class called loan and the method interest to display their rates of interest. Now let us try to execute this program and see the output. As you can see, the program got successfully executed and the rate of interest for loans from different banks is been displayed in the output console. So with this, we have entered into our next topic, where we understand the differences between an abstract class and an interface. So the first difference between the both is the keyword. While we declare an interface, we use the keyword called interface. On the other hand, when we declare an abstract class, we use the keyword abstract. Followed by that, the second difference is when you use an interface, the subclasses basically implement an interface. While on the other hand, when you use abstract classes, the subclasses extend an abstract class and inherit the properties of the abstract class. Followed by that, the third difference is multiple interfaces can be implemented, but on the other hand, only one abstract class can be extended at one particular instance. And the final difference between the both is interface is capable to support multiple inheritance, whereas on the other hand, abstract classes are not capable to support multiple inheritances. Multiple inheritance is none other than the diamond problem, which is not supported in Java. Now that we have understood the differences between the both, let us understand the major advantages and disadvantages of using an abstract class. Now first, we will discuss the advantages. So the advantages of using an abstract class in Java are: the abstract classes are highly beneficial in writing shorter codes. The abstract classes avoid code duplication. They enable code reusability, which is a major advantage. And finally, the last advantage is changes to the internal code implementation can be done without affecting the classes. So these were few of the major advantages of using an abstract class. Now moving ahead, we shall discuss the disadvantages of using abstract classes. Few of the disadvantages of using an abstract class in Java are: abstraction is expensive, as sometimes you need to handle cases and situations which are not necessary. Followed by that, the second disadvantage is object relational impedance mismatch in the case of RDBMS, and the last disadvantage is object relational mapping in case of frameworks like Hibernate. So these are the few important disadvantages of using abstract classes in Java that you need to consider before using them into your project.
Let's see the definition of encapsulation. Encapsulation is like a capsule. The whole code and data is bounded together into a single unit. Another way to think about encapsulation is it is a protective shield that prevents the data from being accessed by the code outside this shield. As you can see, variables and methods are defined inside one class like a capsule. Now the question is, why do we need encapsulation? The main reasons are: first, better control of class attributes and methods. Second, class attributes can be made read-only or write-only. Third, it makes Java code very flexible. This means the programmer can change one part of the code without affecting other parts. Apart from these, encapsulation is mainly used to protect data and increase security of the code. As you can see, to protect the data, variables must be private and they can only be accessed through methods. Now, let's see Java code for encapsulation to understand the concept better. So now let's create a new project. Next, and I'm gonna name it as Encap1. So here we have our main class. We can write the code here. So before writing the code, let me create a new class. Right click, new Java class, and I'm gonna name it as employee. So in this program, we are going to use a classic example of employee using employee name, ID, and salary. So in this class, let me create variables. First, string name, then integer ID, and then int salary. So I can easily use these variables in our main program by creating object of the class. So let me just create the object. Employee is equal to new employee. Now I can use e.id, name or salary, anything I need to. But this program is about encapsulation. So this is an easy program we can do, but in order to secure our programs when we have a large number of program and large number of lines in a program, so we need encapsulation at that time so that data can be secured. So for that, I'm gonna name it as private. Now all three variables are private, so I can't use them. See, we can't see them anymore. If I write ID, we'll get a red color here. So if we go on it, we can see ID has private access. So that means we can't use it directly. Because of this, we need getters and setters that are normally methods that are used for these. So right click, generate, and here you can see getters and setters. So just select all of them and OK. So now we can use these methods instead of direct using the variables. So we can get in the starting, then set, then get, and again set. So likewise it goes like this. So now we have set here. So if I want to declare variable and if I want to put some value inside my variable, so how can I do that? Here you can see get ID or get salary. So if I go for get ID, if I go for e.set ID and I set it as 6, so this shows no error. This means we can use methods to access variables. So let's complete our program now. First I'm gonna set everything. And lastly e.set salary. Let's get it as 30,000. Maybe in dollars or maybe in rupees. Let's just set it as 30,000 for now. So how I'm gonna print it? For this I'm gonna go to a print statement and then name and not set name, but this time I'm gonna go with get name. Get name is to return the value of the name that I have given. So in this case that's Simplilearn. And next will be ID and e.get ID. And lastly salary e.get salary. So this is a simple program that is used to define encapsulation. If we don't use private variables, that becomes a normal program. So when we use encapsulation, we are going to use private every time whenever we declare variables, so that it's secure and no one can access the variables directly. So now let's run the program. And there we go, we have our result. We have executed the program successfully. And as you can see, name Simplilearn, ID 6 and salary is 30,000. So I hope you understood the concept of encapsulation. So the main concept of encapsulation is all the variables can be accessed through methods. So for this we use getters and setters that are inbuilt functions for IntelliJ or NetBeans or Eclipse. So with this, let's move on to our next program to understand it better and how we can manipulate these variables or methods using program. So again, let's create a new project. And this time I'm gonna name it as Encapsulation 2 because it's the second program for encapsulation. And here we have our main program. Now this time I'm gonna use an example of cars. So let me just create a new class and I'm gonna name it as cars. So in this again I'm gonna create 3 variables that are private. So first I'm gonna get string name, then private string price, that means price of the car, and third one top speed of the car. So we can create the program that we did before as it is, but I'm gonna explain you more in depth how we can manipulate these variables or classes. So I'm gonna create a constructor for the class cars, and inside I'm gonna give it as arguments as string name, then string price and string top speed. And I'm gonna give it as this dot name is equal to name. This is so that the class can identify that we are going to give arguments related to that, and the class can return the values of it. So similarly I'm gonna give it as this dot price is equal to price, and lastly this top speed is equal to top speed. So with this we have completed our constructor for it. Now let's have getters and setters for the same thing for these 3 variables. So generate getter and setter, select all and OK. This is a great feature that we have in Java, getters and setters. Otherwise we'll have to type the whole code. So with this, let's move on to our main program. We'll write the code here. First I'll create object of the class cars, And inside this I'm gonna give arguments, or inside this I'm gonna give values that I use in constructor to assign the values without using any c.getName or c.getPrice. So my first was name, so let me just name it as BMW. The second thing was price, so I'm gonna give it as $30,000. And the third one was top speed, so top speed I'm gonna give it as 200 km/h. So we have assigned all the values to the variables and we have created object as well, all in the same line. So this is another way of creating objects, or another way of assigning values to the variables that are private. So if I try to print these, they can be easily printed. So in the starting, name and c dot, so this time I'm gonna give get name, so it automatically gets the value that I assigned to the variables through getters and setters. After that, price c dot price get price, and in the end top speed c dot get top speed. So if I print this, let's execute it, and there we go, we have name BMW, price, and even the top speed. Now if I give spaces between them, it will look neatly. So let me execute it once more, and here you go, name BMW, price $30,000, and top speed 200 km/h. So this is one of our ways how we can declare variables or assign values to the variables without using any getters or setters. So in this method we used only getters to print the value that we have for variables. Now how can we manipulate the variables if we want to change value of them? Now for this, again I can do set top speed or set price. Let the name be as it is. So c dot set price. So price I'm gonna set it as $50,000, and c dot set top speed, let me increase it to 250 km/h. So before printing that, so that we can differentiate which one is new and which one is old, I'm gonna print one more line, stats after updation. So now if I print these values, I'm just gonna copy paste it. So now if I print it, let's execute it. And here you go. First we have name, price, and top speed, then stats after updations. That means after we set the value gets overwritten on the variables, and now we have a new price and top speed and all the details. So this is how you can manipulate variables or values inside the variables.
What is inheritance? There are two other key terms which are not going to be in this agenda, but you should also, when you get to them, make sure you bundle them together as you're understanding these structures. And that's the abstract class and the polymorphism. So what is inheritance? Inheritance is an act through which a new class gets created by acquiring the variables and methods defined in the previous parent class. So when we look at what is inheritance, we can take an example of, say, food. We have veggies, noodles, fruits, where food is the parent, and your veggies, your noodles, and fruits are all subclasses of that. They're all kind of children of food. Why do we need inheritance? We implement inheritance for a multiple of reasons, like creating a possibility to add or remove features, to reduce the code length as we reuse the code, more comfortable to develop and maintain the project. And so if we start looking at, let's say we have a cell phone. We make calls, we have our SMS texting, our communication. On our phone we have our media. We also had a browser on there, because now we have a smartphone. And we look at that, we have our phone set up, and then we have our full smartphone, media, call, SMS, and browser. And we start to kind of link these. Instead of making them separate, we can have the call and the text and then we can have them inherit, we can actually create a media that inherits their qualities. So now you can text your media. Now you can use the browser as part of your call scenario. And I would even add one more example in here, and that is that all programming languages that are object-based are built on inheritance. Java, Python, C++. So this concept of building an object, and then that object then is inherited by everything underneath of it, is important to understand, even in these even as we're looking at more specific cases. So we'll take a look at the components of inheritance. And the most important two components in inheritance, the two major components that are mentioned, are parent class, or the superclass, and the child class, or the subclass. And to see this, let's go ahead and jump into Eclipse and take a look at what the actual code looks like. So the first thing I want to do is go ahead and add in a new package. And we're going to go ahead and call this package inheritance, because that's what we're working with. Oops. Gave me a default Java tutorial in there. Inheritance, finish. And I started off with the Java tutorials, just a went in and created a new project and made sure it was Java based. So we have our package inheritance right here. We're going to go ahead and add in a new class. And we'll go ahead and call this class machine. Now, one of the standards when you're creating classes is to capitalize the first letter. So always remember to do that. In some places, people like to have the whole word capitalized. It really depends on who you're working with. But it is kind of, if it starts with a capital letter, it's probably a class. And so once we have our inheritance, we have our public class machine. Let's go ahead and give it a little bit underneath there to do something. And we'll start with protected string brand. And so whatever machine we're working with, these particular machines are going to be, we'll call them, it'll be a Samsung. Free, they get some free marketing right there for Samsung. So Samsung machines. And then we want it to do something, so let's go ahead and put a procedure in there. And we'll make it public, void, because it's not going to return anything. And we'll call this wash. I guess they're all wash machines. There we go. There's our brackets. A little trouble finding the bracket on there. And let's just have it, during this, we'll just have it do a quick print line. And we'll say initiating cycle. There. And then, of course, our semicolon on the end. All right, so now we have a public class machine. And we're going to get into where we start working with the actual inheritance. You can create an object with this machine. We haven't done anything special to it. It's like any other class you might create in the Java language. And we've added in public void wash, a procedure with no return. That's what the void means. And it's going to print out. And so let's go ahead and create another class in here. New class. And this one's going to be washing machine. Washing machine. And we'll go ahead and hit finish on here. And we come into our washing machine. It's opened up a nice new tab for us. And we might have a private string model name. And we'll change this to model type. Model type equals, so the type of machine is a top load washing machine. So we have a Samsung as the main type of machines we're looking at, and we have top loader or top loading washing machine. And then we're going to add up here extends machine. And so this is the key code we're going to look for, because we want this to have the properties of the machine. So this comes in and says whatever's in machine, we now also have in our washing machine. And then, of course, if we're going to do all this, we need to actually be able to run it. And if we're going to do that, we want to go ahead and add in the public static void main, reserved keywords there. And this is just your standard main startup. You have your string of arguments. There we go. and of course our bracket. And then in here, we're going to take and create a washing machine object. And so here's our wash machine. That's, of course, the type washing machine. And it's going to equal a new washing machine. So we're initiating a new object in here. There we go. And then we want to do something. And if we're going to have it do something, we want it to go ahead. Let's see what happens when we have wash. Remember, our keyword up there was washing machine dot wash. And where did that come from? Well, if we go back into machine, here it is, public void wash. There's the procedure, and it's coming into the washing machine, and this is inherited. That way we don't have to retype that every time we have a washing machine. This could be washing machine. Maybe the next one is, I don't know, a different kind of washing machines. I'm not an expert on washing machines. But we have to do a wash, and then specific to the washing machine in here, we also had the type. And so we can come back up here, or brand. So we can come up down here, we can go system dot println wash machine dot brand plus, put a little dash in there, plus, and then we're going to go ahead and we have our wash machine dot model type. That model type we put in there. So the brand, where does the brand come from? The brand's coming from our machine. We have our protected string, which is going to be Samsung. And then we have our washing machine, which has the model type, which is a top load machine. And if we go ahead and run this, after, of course, we make sure we have that semicolon in on the end there. We come up there, we'll see initiating cycle. Initiating cycle is printed out from machine, and then the Samsung top load washing machine is the second printout line here. And so when we have our wash printout here also, the wash machine wash is initiating cycle, and then we have, that's where that printout comes from. We can go back up here to machine. You can see right here initiating cycle. And then we flip back over to the washing machine. We print out washmachine.brand, which is the machine class, and then washmachine.modelType, which is underneath the washing machine. So let's go over all that. Let's take a look and see what we're talking about here. So we saw in the code the extends keyword. The term extends is a predefined keyword in Java that allows you to create a new child class by deriving the variables and methods from the parent class to reduce code length and improve the performance. And we see that right up here in our public class washing machine extends machine. So the next key thing to talk about is access modifiers. And I kind of breezed over them when I put together the code, but we'll dig in there a little deeper. When we talk about access modifiers, there's 4 different words you really need to know, and that's default, public, protected, and private. And I'm going to tell you right now, default equals public. So what is default? Default access modifier is set implicitly whenever you declare a class without a specific access modifier. By default, the access of a class or method, when declared without a specific access modifier, becomes available to any other method or class within the same package. And in Java, the default is public. So public, a certain class can be declared as public by using the keyword public. Any class or method, when declared as public, becomes available to any class or method declared in the same package. But if a different method or class needs it, it should be imported. And then we have protected. A certain class is declared protected by using the keyword protected. This provides access to the methods and variables of the protected class only to the rightful subclasses and protects the data from any other classes which are not related. And then private. A certain class is declared protected by using the keyword private. This provides the ultimate protection to the data members and the methods of the private class. This procedure is implemented by class to encapsulate the method and members. So we'll take a little, we're actually going to do a different example in here, but I do like this underneath the washing machine. You can see right here we have put in private, a private string. What this means is that only washing machine can access that private string. Where if you have protected, the children can access it. So a protected screen, if you're underneath a machine up here, we have protected, so that when I create the washing machine and extend machine, I can still access it. But if I create a subclass of washing machine and I mark it as private, that subclass is not going to be able to access it. And so it has to do with what layers of accessing. Think of this as a big team project. You create something, do you really want that to cascade down to the next class? Or who do you want to have access to that? Let's go a little deeper to really bring this home, because it's really important to understand this terminology. Let's go ahead and start a new class here, and we're just going to call this particular class Summation. And go ahead and create that, finish. And so our Summation class, it's going to be pretty simple in here. We'll go ahead and do public, so anybody can access it. Just remember, here's our public on there. And then we'll just do a integer, because that's what it's going to return as an integer. We're going to call it add, and we're going to put integer x comma integer y. And then we'll just return x plus y. So real simple. We're just adding two numbers. Here's our two inputs. They both have to be integers. And we're going to return an integer, and it'll be the summation of the two. So real simple class right there. And if we're going to have a summation, then let's go ahead and create a new class, and we'll call this one child. And in our new child class, we're going to go ahead and keep this simple, and we're just going to have our public static main. We're going to have our summation a equals new summation, and then system out print line a dot add 100 plus 200. Pretty straightforward. Everything's public in here. Oops, okay. There's our running, and we see the answer is 300. So this is public. If you remember correctly, we're talking about public. And so when we use the public keyword, any class or method when declared as public becomes available to any class or method declared in the same package. But if a different method or class needs it, it should be imported. So here we go. That's our public setup. It's just open to everybody. Well, everybody that's under the package inheritance. So it's whoever's using that package can now use this particular child. And let's go ahead and add a new class in. And this time we're going to do a parent class. I'll just put that right in there. And we come in with our parent class. You can see right here the parent class itself is public. But what we want to do underneath the parent class is we want to create a protected void, because we're not returning anything, and print. So we're going to do the print there. And this protected print, let's go and put our brackets in there. And we'll do just a simple print line hello world. And once we have the print hello world, we want to go ahead and add a child class to this. And let's see, we had the child class when it took it out a second ago. So we'll go ahead and put that back in. Here's our child class. And for this child class, we want it to go ahead and extend the parent. So inheritance, there's our extend on there. Oops, let me retype that. All right, extends parent. So now the child class is part of the parent class. And we'll go ahead and put our main in there so that it will run it and execute it. And we'll create our child x equals new child class. So we'll go ahead and assign our variable x and initiate it. And then we'll do just the print and see what happens here. So here's our print statement. And we'll go ahead and run this and compile our child on there. And when it comes in there, you see it says print hello world. And so the parent has marked this as protected. So it's protected from objects that are not inheriting it, but the child can still access that information and print it on there. So here's protected. This provides access to methods and variables of the protected class only to the rightful subclasses and protects the data from any other classes which are not related. In a lot of programming, that's usually where you end up, is doing a lot of stuff that is underneath your parent that is protected. You either make them public or protected. A lot of people are sloppy and just make them public, but most of the stuff you want to make sure it's protected. And then we finally have our private, and I'm going to go back here to our child, and we're going to run this. And it's going to come up and say proceed with launch, errors in setup, and then it's going to give us an exception thread main. Compilation error, the method print from the type parent is not visible. And that's because unless you actually initiate the parent, you're not going to see this code because it's private. It's only private to the public, to the parent class. So even if I extend it in child, it will not be available. And that again protects it. That means it's something that you don't want to inherit and cascade down, because maybe it is a piece of code that is going to be changed, and so you don't want all the children to crash every time you make a change to it. So with private, this provides the ultimate protection to the data members and the methods of the private class. This procedure is implemented by class to encapsulate the methods and members. So very important. We have private, and we have protected, and we have public. The more access you want other pieces of the software code to have and other programmers to have, the more public you want to make it. And of course, the default is public. Now, one of the common workarounds for this, because you're going to have protected data, but you still want it to be used by the subclasses, is to create what they call like a get or a, and we'll do it up here. We'll go ahead and do a private integer x equals 5. And then instead of, on your inheritance, instead of having it call it from the child, we might have a get thing, or a get thing. We might have a public, it's going to return an integer, and we might have it say get x. And this simply just return x. And what this means is that when we have something simple like this where it just does a return x, I can go back into my child here, and instead of print x, we'll do x dot get x. And we'll go ahead and print this out. Or yeah, something simple with that. We'll go ahead and do a system print line on this. And when we run this, you'll see it come up. It's going to recompile, and we get our 5. What's happening here is now I've created underneath the parent private information. You don't know what's going on with it. It's protected. You might have a procedure that's protected. In this case, we had the print procedure, and then we access it from the public. And this could have easily have been, instead of, maybe we'll just call it public void public print. Kind of a goofy way of doing the code. There we go. And then it could go in here and access our print. And so we can actually still access this print variable up here by wrapping it in kind of a get or a public function. This allows us to protect whatever code is going on in the parent class, so it can't be messed up, it can't be accessed indirectly, it has to go through the right processes. And so when we get to the child on here, the child can then still has the public processes, but all the other information is protected and is private. It's really important to remember that private right there. This brings us to super keyword. And when we talk about the super keyword eliminates the confusion between parent class method and subclass method. Super keyword is implemented to access a method or constructor that is defined in the parent class. So back in Eclipse, we'll go under parent, and we'll take this, we're going to take the private out of there, so now we have an integer 5. And we'll go ahead and just remove the print because we're not going to do that in the parent. Oops, and the public. There we go. And so let's create a parent that just has one piece of information. It has an integer x equals 5. And then we're going to go to the child, and let's go ahead and add in here integer x equals 10. And these are, by default, they're public. We haven't set anything on here telling it what it is. And so what I'd like to do is we'd like to go ahead and create a, oops, one more thing, there we go. Create a procedure here, and we'll just call this void capital print. And it's just going to be a system out print line. And this is what I want you to notice is we're going to print out x and super x. So we have the child class x and we have the parent class super x. And if we come down here and we do x dot print, don't forget my semicolon, add a couple spaces in here to make it look nicer when we print it. And we'll go ahead and run this. And you can see that the child class prints 10 and the parent class is 5. And so this way you can actually store different information depending on what it is you're working on and what you're doing. And that's where this super comes in. You can see right here where the super underneath the class and the print module. Now you can't just put it in down here under print. Let me explore what that looks like. If I just take this and I go ahead and highlight it. And let's say I wanted to just, instead of doing xprint, it's going to come up right here. And right off the bat, you see the super.x. I could do x.super.x, and it's still going to give me an error right here. It has to be underneath a procedure in the actual class and not under the main. This brings us to types of inheritance. And there's 4 main types. We have single inheritance, which we've already pretty much looked at, but we'll go back over. We have multi-level inheritance. We have hierarchical inheritance and hybrid inheritance. Let's go ahead and just start with the single inheritance. Single inheritance consists of one parent class and one child class. Here, child class inherits parent class methods and data members. And let's go ahead and create a new class up here, just to change it up and keep it interesting. New class. And we'll call this one student. And under the student, we'll have a simple setup. We'll just do an enrolled, and it'll say enrolled in Simplilearn. There we go. So there's our class student, and then we'll create another class. We'll do it as because we have our student, our base student, and then we'll call this one new class. And we'll call this one computers. There we go. So he's enrolled, finish. And for computers, let's go ahead and put in a print line here. And we'll put down studying computers. And we want to go ahead and do the extends student. So it's a student studying computers, subclass computers. And this would all look familiar because we've been doing this for, a lot of the other setups. This is your basic inheritance. And we'll change that from enrolled to studies. And then let's go ahead and put a main in here so we can actually run it. And we have our P enrolled, which comes from our parent class, and our P studies, which comes from the child, or the one that inheritance it, the extends for student. And let's go ahead and run that. There we go, run. And you can say enrolled in Simplilearn studying computers. And then we can go on to the next setup. And this is where we look at multi-level inheritance. It is also a parent-child inheritance relation, but the difference is the child class is inherited by another child class. This is the basic structure of most programming languages right here. You have an object, you have all the different things under the object, and it gets all the way down to whether it's an array you're working with, whether even a class is a subchild that goes all the way up to the object. And we can simply do that in our code in Eclipse. And we'll just go ahead and add a new class in there. We'll call this one Java. There we go. Oops, Java. And under Java, we want to go ahead and create some of the similar stuff. And then I want to go back to my student. I took out the main in student just because I don't want it to run the main in there. And in here, we're going to have system out. We're going to have, instead of studying computers, focus on Java, which is what we're doing right now. And maybe we'll call this classroom. And then we can come down here and we have our P equals new computers. Well, instead of new computers, we want our Java. And it's going to be a Java object. And we need to put our extends in up here. Extends, in this case we came from computers. So there's our initial thing. And then we have our last print in here. And of course, if we run this now, we'll see that it should, if I did everything correctly, come up and say, enrolled in Simplilearn, studying computers, focus on Java. And we have the enrolled, which is the parent to computers. And then we have under computers, well, we have student, then computers, and then Java. And so each one of these classes just cascades all the way down. And this is your multi-level from your class A to class B to class C. And if you can have multi-level inheritance, we can also have a hierarchical inheritance where your parent-child relationship, the only difference is here multiple child classes inherit from one parent class. And that is pretty, we'll do another class here. If you remember correctly, we had student, computers, maybe from student we'll have, instead of computers, we'll have project management. Project management. So you're studying your IDLE and all your other classes in there for Cascade and for doing agile programming. And in here we can do that. And it's just the same as we did before. We just have a second child coming in from here. And so this would go ahead and extends student. And of course, whatever subcategory you have one in here for running this. And so for here, we'd have like our void studies. In this case, instead of studying computers, we're studying project management. One of the other wonderful classes that is taught from the Simplilearn team. And we'll go and run that, and you can see right here we have computers. Oops, of course, instead of computers, I meant to do project management. There we go. And we have to also initiate it as a new. And then when we run here, we can see this. We're enrolled in Simplilearn and we're studying project management. And then finally there is the hybrid. The name itself explains it to us. The hybrid inheritance can be a combination of any of the three types of inheritance supported in Java. And so maybe we already saw that because we have our A and our B. If we flip back on over to our Eclipse, we have our student. Our student now has a computers, project management. So there's our hierarchical, and then they're mixed because we also have the Java, which is an extension of the computer. And so we have multiple layers there. So one of the issues that comes up with inheritance in classes is what they call the diamond problem. And in the diamond problem, the Java programming language does not support multiple inheritance as it ends up with serious ambiguity. And that is where we have D, which inherits from both B and C, which might both inherit from A. This is the diamond factor because as you start tracking your supers going up, which one are you actually looking at, B or C or A? And that's why they call this the diamond problem. It comes up more than you would think. You get very complicated structures and you realize, oh, I need to have both sets of instructions come down to whatever I'm working on. And you can see where that can become a problem. Let us take a look at is a relation and has a relation. Now these, I mean, they're vocabulary, but they're more of a concept, understanding how things fit together. And so when we talk about is a relation, when a class inherits methods and members from a different class, then the relationship is said to be is a relation. Examples, orange is a fruit. And let's just jump back on over here and we'll make a new class. And we'll call this class customer. So we're going to have our customers. Oops. There we go, if I can remember how to type. So we have a class customer, and I've gone ahead and our team in the back went ahead and prepped this for us. Let's just take a quick look though. We got public string name, so it's accessed publicly. If you leave this out, it'll automatically be public because that's the default. And then we have our customer and the string, which is a name, and a string is a city. And then when you do a customer and you send it the name and the city, it will do this name equals name and this city equals city. We could have easily done this private. We have a call into it to create it. So it wouldn't really matter too much whether we did it private or public. I would actually be more likely to do it private. And for this example, we'll go ahead and create another class, and we'll call this store. We'll have our store class. So we have customers and we have a store. And then we'll go ahead and set up in here. And this time we did do a private. We're going to create a list of customers, and then the store list coming down, and then this customers, and public list customers. A quick look at this is we did make this one private, which is nice because now it can't be accessed externally except from store. And then store has the public list customers, so we can send it a list of customers, and then it go ahead and returns the customers from that list. And then when we add it to the store, it sets the customers in the store. This dot customers equals customers. One of the reasons we have the error lines in here is I haven't compiled it, so it doesn't see the customers are part of our package. And we'll get to that in just a moment here. And then let's go ahead and create another class. We'll call this isARelation, since that's what we're working on. And here's our isARelation setup. And we're just going to put this as the main, so you have your main in there. And then we went ahead and prepared a series of customers. And we'll just call it customer C1 equals a new customer, customer C2 equals a new customer. And we're just creating a list here. That's all we're doing. And if we're going to have a list, then we need to go ahead and create a list of customers. And we'll just do that with a simple list setup. And then we got to add those customers into the list. So let's go ahead and do that. So breaking this down, we have customer 1, which is Raju, Bangalore, Shiva, Hyperbad, Sachin, Mumbai, and so on. And then we just created a list of customers, a new array of lists, and then we add in each of those customers. So now we have a nice list of all our different customers in here. And then we want to go ahead and create our store. And we'll put in store, and it'll be a Fruit Smoothies franchise. I put down Fruit Smoothies Franch. Maybe that's not a good abbreviation because you might think it's a French instead of franchise. But it'll be a new store. And then we have our new store, which is, in this case, we're going to put in that new store customers. And if you remember, we went back here into store. Let me just flip back on over there. It's going to take that list of customers and put that into this customer. So now the private list is going to equal that list of customers. And then, of course, we can come in here and we do public list. It's going to return that list of customers. So we have public assets here, and this store, you can add public at the beginning. We'll go ahead and do that just to make it clear. Is it public? Is what's going to run on there. And let's go back into our isARelation. And flip back to store. I'm going to go ahead and just change this to customer list. So here's our list, customer list, and it's going to return the customers from this selection, from our private variable. So we come into here. We can come down here and we'll go ahead and put that in there. We'll do a loop on this. We'll have a list customer, and we're going to create a list of our customers from our Fruit Smoothies franchise, and we'll get the customer list from there. And then for a customer in the for customer CST in customer, we're going to go ahead and just print that name out there. Now at this point, if you have an error showing up here under list and also underneath array list, depending on how you did your install, you might have to go ahead and import those, your array list from your Java utility. Not a big deal. And then once we go ahead and we have this all set up, you'll see here the compiler goes through, and then we have the name of the customer, city, and then it just lists the customers going down here. So when we talk about our relationship of our Fruit Smoothies franchise and customers, the customers, they are a relationship directly to the French Smoothies franchise. Now, the second idea is it has a relation. And let's go ahead and take a look at that and see how that differs. And we'll go ahead and create a, let's see. We had customers, so let's do, and we'll call this one, we're doing with smoothies, so we'll have flavors, or favorite. We'll do favorite flavors. Favorite flavors for a class, very strange class. And let's see, in favorite flavors, we'll go ahead and give it a couple things to look at. We'll have a private string and a name. And then we'll have a public string get flavor. There we go. And that's just going to return return. We'll just have that return the name of the flavor. There we go. And then we want to go ahead and create one more class, and this class we'll call has a relation. And I'm hoping you're guessing where we're going with this. Let's go ahead and put some code in here to make it work. And let's go back to our favorite flavors and put in a constructor so that we can load the flavors. And then return this name so we can return the flavors. We'll go back into has a relation. And let's just create a customer. We'll call it cust. Our new customer is Toby Marshall from Mumbai. And our favorite flavors are strawberry, banana, and peanut butter. I don't know, it's a strange concoction. And then we run a print line. We're going to print the customer name from customers and the flavors get flavor. And so when we're looking at this, what I want you to be aware of is that neither the flavors nor the customer are in the same class. They're not, it's not an actual relationship, but they have a relationship, because we have Toby who happens to like strawberry and peanut butter. And if you remember, just a quick note, we were looking at the diamond problem. You can create a class that then has these two subclasses in. And that's how you go around the diamond problem, is you don't inherit, but you create classes inside the class you're working with. What is polymorphism? According to chemistry, the term polymorphism can be defined as the ability of any element or compound to exist in multiple crystalline forms. This is called polymorphism. For example, if you have the carbon atom, it can come out in different forms in coal, graphite, and diamond. What is polymorphism in Java? Similarly, in the terms of Java programming language, polymorphism is defined as the ability of any object in a class to perform a particular task in multiple methods. This is known as polymorphism in Java. We're going to open up our Eclipse editor, and we're going to do some animal sounds with cows, cats, and dogs, just kind of a fun, almost kids-like example of polymorphism. And you can see I already have my inheritance in here. Let's go ahead and create a new package, and we'll call this polymorphism, just to keep it simple. And once we have our polymorphism in there, we're going to go ahead and add a class in. And if you were doing an abstract class, we can label it as abstract because we're not going to directly access it. And we'll call it animal sounds. Maybe we will. We'll see how we load the program up. But we'll call this animal sounds. And let's create a public, it's not going to return anything, but we'll call it sound on here. And we just want to go ahead and have it do a system out print. And with our system out print line, we'll just have it say animals make different sounds. There we go. So yeah, it's really simple and straightforward. We're just going to have it print something out. And if we're going to do that, let's go ahead and just Good thing I didn't make it abstract. Let's go ahead and just test it out and see what it looks like. And we'll do, we'll call it animal main. Animal main. And in here, let's go ahead and test out what we just put together. We'll do our static void main, so it's going to run on here. And we'll create our animal sounds. We'll call it animal, because we don't know what kind of animal this is. We'll call it new animal sounds. And we'll just take that animal, and I like to put it in capitalized, but usually we like to do this lowercase. There we go. And we'll just have our animal dot sound end. And let's go ahead and run this and see what comes out. We can see here animals make different sounds. Okay, that's not too exciting. So let's jump in there and let's say we have, in this case, we're going to add in a couple of different animals. We'll add in a, let's start with a cow. Yeah, why not a cow? So we'll have our cow in here. We'll go ahead and click OK. And now we have our cow class. But a cow doesn't just, it makes different noises, but it actually makes a very clear noise. So we'll go ahead and give the cow a sound. And we'll have the cow say moo moo. And the cow is going to extend. There's our, and we'll put in our extends animal sounds. And then I want to go back here to our animal main. And now we have a class cow. So in our animal main, we want to do cow equals new cow. And once we've created the new cow, we also need to go ahead and have the cow sounds. There we go. And we run this. You can see it comes out here and it says the cow says moo moo. So if we go back to cow, we're just going to do this real quick. And let's say we just take this out of here, the public void sound. And then we're going to go into our animal main and run that. Recompiles. Animals make different sounds because it doesn't know what sound a cow makes. So this is really central to polymorphism, is we're taking something going on in the in one setup that we've brought in and extended from our animal sounds, and we've changed it to the cow says moo moo. And we can also add in multiple animals in here. We'll go ahead and just add in one more animal. We'll call this one, we'll do a dog, why not? So here comes in our dog, and of course we want the dog to actually say something. And we'll have the dog go bow wow, and then we'll go back to our animal main, and we have to create a dog. And we'll say cow, simply dog, dog, uppercase for the class, lowercase for the actual object. And then of course we need the dog to make a sound, so we'll go down here and go dog dot sound. And when we run this, as you expect, the it's going to compile it. There we go. Animals make different sounds. The cow says moo moo. The dog says bow wow. Characteristics of polymorphism. The functionality of a method behaves differently in different situations. The behavior of a method is dependent on the data. Polymorphism is mainly used to implement inheritance. As we saw, we did the extends with the animal sounds. Polymorphism is mainly used to implement inheritance. It allows same name for a member of method in a class with different types, which we'll cover briefly in a minute. Polymorphism supports implicit type conversion. Types of polymorphism. There are basically two types of polymorphism that can be occurred in Java programming language. They are mentioned as follows: compile time polymorphism, runtime polymorphism. Compile time polymorphism gets executed during the compilation stage. Here the overloading method gets resolved in compilation stage. So when you saw me run those in Eclipse and it went through the compile time, that's looking at all the different changes we made to those classes. That's what we're talking about here, is during compile time. In method overloading, In Java, the process of method overloading is achieved when a class has two or more methods with the same name, but the specific method is selected based on the number of parameters declared. We'll now execute a program based on the functionality of additional operator in a different situation. And let's flip back on over to our Eclipse. So in here, I'm going to go back under the dog, and let me just highlight this. And we're going to do the same thing. So you see right here it says public void sound. So this is identical, public void sound. But instead of sending nothing, we're going to send it a string, and we're going to call it angry. Now at this point, you should note that what if it's a happy dog? I would have to add an if-then. If the string angry said happy, then we'd print happy or something else. But we're just keeping it simple. So we've entered another sound identical to the first, but we've added string angry to it. And this is going to print out the dog says growl, growl. Now if we go back to our animal main, and here's our dog, same sound. But now we're going to add a string in here. And we put that string in here, we'll go ahead and just call it angry. It doesn't really matter what string you put in here because we haven't sorted out what the string means. For now it just says growl, growl. It's going to recompile it. So remember, this is a polymorphism during compile time. And here we have it, the dog says growl, growl. So the dog says bow, wow, and then the angry dog says growl, growl. So there's another thing called operator overloading. Operator overloading is not supported in Java. Authors of Java wanted to keep the language less complicated. Explaining operator overloading, it basically is a way of bundling operations into the call statement and user procedures. It's so that it looks like a math on a paper. You have A plus add B plus C kind of thing, and it's all wrapped up in your call to another statement. This just gets confusing, and it really isn't necessary. So the Java developers decided not to put it in there. So runtime polymorphism. In Java programming language, runtime polymorphism gets handled during the program execution stage. Here the overriding method gets resolved in execution. So far we've talked about compile time polymorphism. As you saw in the program we just wrote, when it's compiling, it does the extend and figures out which overload method to use on there. In runtime polymorphism, method overriding, in Java, the method overriding is a procedure where a child class is allowed to implement a specific class that is already provided in the parent class. For runtime compilation code, or polymorphism, we need to go ahead and introduce the super keyword. Now, from inheritance, you should remember that we can look at super from before, but we're going to use it slightly different. It's kind of doing the same thing as when we did the inheritance, but we're doing like what they call an override during runtime. So the term super is predefined keyword in Java that is used to refer the immediate parent class object or method defined in the program. In this procedure, whenever you create an instance of subclass, then automatically an instance of parent class is also created that will be implicitly referred by the super reference variable. So going back into our animal sounds, let's go in here to dog. And if we add a super dot sound in here, this is going to reference whatever our extend is, because the dog extends animal sounds. And so here's our super dot sound. And if we go ahead and we'll run and compile this, and you can see here that it comes down and it says the dog says growl, growl, because that's what we had it system out print line to. And then the super, animals make different sounds. And so if we go back to our animal main, this is what it's calling right here. It's going back into sound under the animal mains, and it's printing out or doing whatever it does here. At this point, we usually have it return something, so you can look up whatever the original class was using. So getting back to these two setups, whether you're using the super to use a runtime polymorphism, because that's what's happening during runtime, versus compile time polymorphism. During compile time polymorphism, method call is handled by the compiler itself. So the program maybe take a second more to compile, but it runs faster. In the runtime, the method call cannot be handled by compiler in the execution stage. So if you have any errors, it's not going to show up either. During the compile time, we have compile time polymorphism is less flexible as it needs handle all method calls in compile time. So you really, in runtime polymorphism, it exhibits higher flexibility as a method call gets handled at runtime coming in. The execution period for compile time polymorphism is less. That's what I was just talking about. It compiles it, so the compiling takes maybe a little bit more. But if you're executing the same program over and over and over again, once it's distributed, it's going to run faster. Then, of course, with the runtime polymorphism, the execution period for runtime polymorphism takes longer. It's just a little bit more. Usually in most programs you don't notice this, but if you're executing the same script 1,000 times, suddenly that 0.01 second is a lot more. It suddenly is adding up a second each time it goes through the 1,000 iterations. Then with the compile time polymorphism, integrating the right method call with the right method is done in compile time. And of course in runtime, integrating the right method call with the right method is done in runtime. Again, that's another delay because it has to figure out what it's doing. It's not already pre-mapped out. And finally, compile time polymorphism occurs during method overloading and operator overloading, where runtime polymorphism occurs during the method overriding. Advantages of polymorphism: programmers' code can be reused via polymorphism. Number one goal of a programmer is to reuse the code as much as possible so you're not reinventing the wheel over and over again. Advantages of polymorphism: supports single variable name for multiple data types, reduces coupling between different functionalities. And some of the disadvantages of polymorphism that can come up is that polymorphism ends up raising performance issues in real time. You can see where as you're loading all these different things, you might end up creating loops you didn't know you were doing. Polymorphism reduces readability of the code. Sometimes your actual code, everything you look at in Java is polymorphism, all based on a primary object. So you could have a very complicated setup, and then it actually is very easy to read when you actually put your final variable in there. But when you're going through lines and lines of code, it can be really hard to figure out what's going on as you loop through all these different inherited modules or classes. Programmers find polymorphism difficult to implement. Just depends. The more you use it, the easier it is.
What exactly is a Java collection? A Java collection can be generally defined as a collective unit of objects in the form of a group. For example, a group of numbers of integer data type, etc. Moving forward, we enter into our next topic, where we face the Java Collections framework. This will help us understand Java collections in a little more detailed way. A Java collection framework represents a unified architecture for storing and manipulating a group of objects. Its architecture includes the following: an interface, a class, and the Java Collections API. To understand these in a much better way, we shall now go through the Java Collections hierarchy. The utility package java.util contains all the classes and interfaces that are required by a collection framework. The collection framework contains an interface named as an iterable interface, which provides the iterator to iterate through all the collections. This interface can be extended by the main collection interface, which acts as the root for the collection framework. All the collections extend this collection interface, thereby extending the properties of the iterator and the methods of this interface. The following figure illustrates the hierarchy of collection framework. Out of the complexities, we have the interface and the classes as the major part of the collections. Now, let us understand each one of them at one step at a time. As you can see on the screen, we have the iterable class, which is implemented by the collection class, and this particular collection class is further implemented by list, queue, and set. And moving ahead, we have the following classes which have implemented the list, queue, and set classes. In the list, we have array list, linked list, vector, stack, and on the other hand, on the queue, we have priority queue, dequeue, and array dequeue. And finally, on the set, we have the hash set, linked hash set, sorted set, tree set, etc. Now moving further, we will enter our first Java collection, which is none other than the interface. So the first one is an interface. An interface can have methods and variables, but the methods declared in an interface are by default abstract. That is, only the method signature is available, not the body. Interfaces specify what a class must do and not how it must do. It is a blueprint of a class. Now, a Java collection is a foundation to the Java Collections framework. Note that All the collection interfaces are generic. For example, public interface collection is the syntax for the generics, and when we declare the collection, we should use it to specify the type of object which it can contain. It helps in reducing runtime errors by type checking the objects at compile time. To keep the number of core collections interface manageable, the Java platform doesn't provide separate interfaces for each variant of each collection type. If an unsupported operation is invoked, a collection implementation throws an unsupported operation exception. Now, under the collection interface, we have many interfaces that we should use for data manipulation. A few of the major ones are set interface, list interface, dequeue interface, queue interface, map interface, sorted set interface, sorted map interface. Don't worry, those are a lot of interfaces, but we will discuss each one of them in a detailed way along with a practical example for a better understanding. So the first one in the docket is the set interface. A set is a collection that cannot contain any duplicate elements. This interface model is the mathematical set abstraction and is used to represent sets such as a deck of cards. The Java platform contains three general-purpose set implementations: the hash set, tree set, and linked hash set. The set interface does not allow random access to an element in the collection. You can use an iterator for each loop to traverse elements of a set. Now, for a better understanding, let us go through a practical example. I have prepared a code document for all the programs that I am going to explain to just save time. You can always have access to it. All you need to do is just ask for it in the comment section below. So you can see on my screen we have an example for set interface. In this particular example, we are going to store the elements 21, 23, 43, 53, 22, and 65. So let's try to execute this program and see the output. So you can see the elements stored in the set interface are 65, 21, 53, 22, and 23, 43. So the sorted set is here, which is the 21, 22, 23, 43, 53, and 65, and the first element being 21 and the last element being 65. So this is how the set interface practically works. Now let's move ahead into our next type of interface, which is none other than the list interface. So what exactly is a list interface? The list interface is an ordered collection that can contain duplicate elements. You can access any element from its index. The list is more likely an array with dynamic length. The list is one of the most used collection types. An array list and linked list are the implementation classes of the list interface. The list interface provides useful methods to add an element at a specific index, to remove and replace elements based on the index, and to get a sublist using the index. For a better understanding, let's check out an example. So this particular program is based on list interface. So we are going to add in three names, which are David, John, and Stacy, into our list, and also we have a fourth addition, which is Stacy again. Just to check if the statement is true, it says list interface also allows duplicate elements unlike the set interface. So let's try to run this program and see the output. So you can see the program got successfully executed and the names David, John, and Stacy are added into the list. Now let's come back to our program and remove this comment and try to run again and check if the fourth element, which is the duplicate of the third, Stacy, will be added into the list or not. So as you can see, the program got successfully executed and the fourth element, which is Stacy, the duplication of the first one, got successfully inserted into the list. So this is how the list interface works. Now let's move ahead into our next type of interface, which is the queue interface. So what exactly is a queue interface? Queue is a collection used to hold multiple elements prior to processing. Besides basic collection operations, a queue provides additional insertion, extraction, and inspection operations. Queues typically, but do not necessarily, order elements in the FIFO or first in, first out manner. Among the exceptions are priority queues, which order elements according to a supplied comparator, or the elements in natural ordering. whatever the ordering used, the head of the queue is the element that would be removed by a call to remove or pull. In a first in first out queue, all new elements are inserted at the tail of the queue. Now for a better understanding, let's go through a practical example. So as you can see, the program on my screen is an example for queue interface. So in this particular queue, we are going to store the names of fruits: apple, mango, grapes, and banana, and apple being the head of the queue and banana being the tail of the queue. Now let's try to execute this program and see the output. So we are also going to count the size of the queue, which is 4 basically in the first. After that, we are going to remove the element grapes from the queue. So the command is queue.remove the element name. So after that, the grapes element has been removed from our queue. We have the latest size of the queue as 3. Now after that, we are also going to check if the element apple is included in the queue or not. So for that statement, yes, the element apple is included in the queue and the result is true. So this is how the queues work, and let's move further. And in the next phase, we have the DQ interface. So what exactly is a DQ interface? So a linear collection that supports element insertion and removal at both the ends is called as a DQ interface. The name DQ is short for double-ended queue and is usually pronounced as DEQ. Most DQ implementations place no fixed limits on the number of elements they may contain, but this interface supports capacity-restricted DQs as well as those with no fixed size limit. This interface defines methods to access the elements at both the ends of the DQ. Methods are provided to insert, remove, and examine the element. For a better understanding, let's check out an example. So you can see on my screen we have a program for DQ interface. So here we are going to add in some elements into our DQ and then also try to remove the first element and print the updated DQ. Now let's try to execute this program and see the output. So as you can see, the program got successfully executed and the elements which we tried to push into the DQ were 52, 10, and 21. 52 is being the first element and the 21 is being the last element. So we tried to remove the first element, which is the 52. So after that, the updated DQ is having 2 elements which are 10 and 21. So this is how the queues work. Now let's move ahead and learn our next type of interface, which is the map interface. So what exactly is a map interface? A Java map is an object that maps keys along with its values. A map cannot contain duplicate keys. Each key can map to at most one value. The Java platform contains 3 general purpose map implementations, which are the hash map, tree map, and linked hash map. The basic operations of a map are contains key, contains value, size, and is empty. For a better understanding, let us check out an example. So this particular example on my screen is an example for map interface. Here we are going to add 3 elements and map them as 1 as cricket, 2 as hockey, and 3 as archery. Now let us execute this program and see the output. So you can see the program got successfully executed and the elements are mapped with their keys, and the element cricket is mapped with the key 1, and similarly hockey with key 2 and archery with the key 3. So this is how the map interfaces work. Now let's move further into our next type of interface, which is the sorted set interface. So what exactly is a sorted set interface? So a sorted set is a set that maintains its elements in ascending order. Several additional operations are provided to take advantage of the ordering. Sorted sets are usually used for naturally ordered sets, such as word lists and membership roles. For a better understanding, let's check out an example based on sorted set interface. So you can see the program on my screen is an example for sorted set interface. So here we are going to add in Bob, Sean, and Jennifer into our set, and we are going to print the same. Let's try to execute this program and see the output. So you can see the program got successfully executed and we have our elements printed in the sorted set, and you can see the names have been arranged in the form of ascending order according to the alphabets which have started in the first position. So this is exactly how the sorted set interface works. So the last one in the interfaces is the sorted map interface, a map that maintains its mapping in an ascending key order. This is the map analog of sorted set. The sorted maps are used for naturally ordered collections of key value pairs such as dictionaries and telephone directories. Now for a better understanding, let's check out an example based on map interface or sorted map interface. So you can see the program on my screen is an example for sorted map interface. So here we are going to add in the elements John, Molly, Aaron and Daisy into the map interface. Now along with the names, we also have their aggregates, which is 76.5 for John, 87.3 for Molly and 78.2 for Aaron. And for Daisy we have 73.4. Now finally we are going to fetch the data of Molly, which is the aggregate of Molly. Now let's try to execute this program and see the output. So you can see the program got successfully executed and Molly's aggregate is 87.3. So this is how the map interfaces work. Now let's move ahead into our next topic, which is the Java collection classes. So now that we have finished the Java collection interfaces, let us have a quick understanding of Java interface methods. So the first method is the add method. The add method is used to add an object to the collection, and next is the isEmpty method. This method returns the true if the collection contains no elements. Followed by that we have the clear method, and this method is used to remove all the elements from the collection. Followed by that we have the remove method. This method is used to remove the given object from the collection. If there are duplicate values, then this method removes the first occurrence of the object. Next to the remove method we have the size method. So the size method is used to return the number of elements in the collection. So after the size method we have the stream method. The stream method is used to return a sequential stream with this collection as its source. So the next method we have is the toArray method. So the toArray method is used to return an array containing all the elements in this collection. Followed by that we have the hashcode method. This method is used to return the hashcode value for this collection. Next, the equals method. The equals method is used to compare the specified object with the remaining elements in the collection. Followed by that we have the iterator method. So the iterator method is used as an iterator over the elements of the particular collection. And finally we have the contains method. So the contains method returns true if a specified element is existing in the collection and false if it is not present. So with this we finish the collection interface and collection interface methods. Now we will move ahead into our next topic, which is none other than the Java collection classes. So what exactly is a class? A class is a user-defined blueprint or prototype from which objects are created. It represents a set of properties or methods that are common to all the objects of one type. Now we'll start up with the first one, which is the hash set class. So the Java hash set is the basic implementation of the set interface that is backed up by the hash map. It makes no guarantee for the iteration order of the set and permits null elements as well. So this class offers constant time performance for basic operations such as add, remove, contains, and size. Assuming the hash function disperses the elements properly among the buckets, we can set the initial capacity and load factor for this collection. The load factor is a measure of how full the hash map is allowed to get before its capacity is automatically increased. For a better understanding, let's go through an example. So on my screen you can see a program which is an example for hash set classes. So inside this we are going to store some names which are the names of the manufacturers of bikes along with null values. So we have added in two null values to just check if it allows two null values at once. So basically it only should allow one null value. So let's check out how does it perform. So you can see the program got successfully executed and the null value is stored only once, that too in the first location. So this is how the hash set classes work. Moving further, we will deal with the next type of class, which is the tree set class. So a tree set class is a navigable set implementation based on a tree map. The elements are ordered using their natural ordering or by a comparator provided at set creation time, depending on which constructor is being used. This implementation provides guaranteed logged time cost for the basic operations such as add, remove, and contains. Note that the ordering maintained by a set, whether or not an explicit comparator is provided, must be consistent with equals if it is to correctly implement the set interface. Now, to understand in a much better way, let us go through an example. Now we are going to add in some numbers into the tree set using the add method. Now let's execute this code and see the output. So you can see the numbers are added into the tree set and the numbers are ordered in ascending order, which is 0, 18, 88, 748, 983, 8476. Now let's move further into our next type of class, which is the array list class. So array list in Java is a resizable array that is an implementation of list interface that allows null elements. So in this class we have three types of arrays, which are one-dimensional arrays, two-dimensional arrays, and three-dimensional arrays. Now let's check out the one-dimensional array. So a one-dimensional array looks similar to this, where we have the array index and the element present in the array. So here our indexes are A0, 1, 2, 3, and 4, and the elements which are shown here. To understand one-dimensional arrays in a much better way, let's go through a sample program. So you can see the program written on my screen is an example for one-dimensional array, and we are going to store the elements 10, 20, and 30 into my array A. So you can see the program has been successfully executed and the elements have been added into my one-dimensional array. Moving further, we will discuss the two-dimensional arrays. The two-dimensional arrays are completely similar to one-dimensional array, but the only difference is the index numbers. Earlier we had index number, but now we have index numbers. Now using these index numbers, we can represent the elements in a matrix form. So to understand this in a much better way, let's go through a sample code. So you can see this particular program in my screen is an example for two-dimensional arrays. So here we are going to add in elements 1, 2, 3, and 4 in the matrix form, and we are going to use two for loops to print that. Now let's execute this program and see the output. So you can see we have the elements 1, 2, 3, and 4, and the elements are printed in the matrix form. At the array index location 0, 0 we have 1, 0, 1 we have 2, and 1, 0 we have 3, and 1, 1 we have 4. So this is how the two-dimensional arrays work. And finally, let's deal with the third type of array, which is the multi-dimensional or three-dimensional array. So you can see the three-dimensional array is completely similar or a little bit similar to the two-dimensional array, but the only difference is we have a third vector here. So next up we have the linked list. Linked lists also come under Java collection classes. There are three types of linked lists, which are single linked list, doubly linked list, and circular linked list. Now let's check out each one of those. So the first one is the singly linked list. So you can see in a singly linked list, each memory segment is divided into two parts. So the first half of the memory location is given for the element, and the second half of the memory location is dedicated for the address. So this particular address is used to point to the next element or the next memory allocation, which stores the second element, similarly the third. So this is how the singly linked list works. So the last memory allocation is called as the tail, and the last address will not store nothing but null, which indicates the end of the singly linked list. Now to understand singly linked list in a much better way, let's try to execute a sample program. So you can see the program on my screen is an example for singly linked list. Now we are going to add in the elements 1, 2, 3 and 4 in the form of a singly linked list. Now let's try to execute this program and see the output. So you can see the program got successfully executed and the elements are 1, 2, 3 and 4. Now let's move further and try to learn the next type of linked list, which is the doubly linked list. So the doubly linked list is completely similar to that of the singly linked list, but the only difference is we have two address locations. So the first address location of the head stores null and the last address location of the tail stores null, which indicate the start and end of the doubly linked list respectively. So here in the second memory location you have two addresses. So the first address points to the previous element and the next address points to the next element. So to understand doubly linked list in a much better way, let's try to execute a sample program. So as you can see, the program on my screen is an example for doubly linked list, and we have the node which has the data and previous address, next address. Now let's try to execute this program and see the output. And the elements that we are going to store in this particular doubly linked list are 1, 2, 3, 4 and 5. So as you can see, the program got successfully executed and the nodes are 1, 2, 3 and 4 and 5. So this is how the doubly linked lists work. And now let's check out the third type of linked list, which is the circular linked list. So there are similarities between the previous linked list and the circular linked list. So the circular linked list makes it circular based on the last address location. So this particular address location points to the first element back again. So this is how it becomes a circular linked list. So to understand this in a much better way, let's check out an example for it. So you can see the program on my screen is an example for circular linked list. Now let's try to execute this and see the output. So you can see we have successfully included 1, 2, 3, 4, 5, 6 and 7 and 8 into our circular linked list, and they are printed on the screen. So this is how the circular linked list work. So moving further, we will try to understand the next type of classes in Java collections, which is the HashMap class. So hash table is based on the implementation of map interface. This implementation provides all the optional map operations and permits null values and the null key. HashMap class is roughly equivalent to hash table, except that it is unsynchronized and permits null. This class makes no guarantee for the order of the map. Now for a better understanding, let's go through a sample program. So this particular program on my screen is an example for HashMap class. So here we are trying to load the data, which is the name of the manufacturer and their bike. So let's execute this program and see the output. So you can see the program got successfully executed and we have the manufacturer and their made bikes. Now moving further, we will deal with the next type of class in Java collection, which is the tree map class. So the tree map is based on navigable map implementation. The map is sorted according to the natural ordering of its keys or by a comparator provided at map creation time, depending on the constructor used. Now let's check out an example for better understanding. So you can see the program written on my screen is an example for tree map class. So we have the roll numbers and the names of students here. Now let's try to execute this program and see the output. So the program got successfully executed and the result has been printed on the output console. So we have the roll numbers of the students and their names: Amber, James, Violet and Reynolds, along with their respective IDs. So now with this, we complete the Java collections classes. Now we move into our next topic, which is the collection API algorithms. So the first one is sorting. Sorting does the job of ascending and descending numbers based on the algorithm written by the user. For a simple example, we shall consider the bubble sort algorithm for this one. So you can see on my screen we have an example for bubble sort algorithm. So we have the elements 2, 89, 39, 48, 6, 28, 1, 2 and 33, which are ordered in an unorderly manner. Let's try to execute this program and order them. So you can see array before bubble sort is 289, 38, 48, similarly 33, and after the bubble sort we have the sorted array, which is 1, 2, 6, 28, 33, 39, 48 and 289. So this is how the bubble sort works. Now let's move further and understand the next type of API, which is the shuffling algorithm. So the shuffling algorithms are designed to destroy the current arrangements. They are employed on creating randomness in the list. So for a better understanding, let's check out an example. So you can see the program written on my screen is an example for shuffle algorithm. So we have an array which has the elements completely sorted in ascending order, which is 10 to 100. Now when we run the shuffle algorithm, these elements will be completely shuffled according to a random order. Now let's try to execute this program and see the output. So you can see the elements which were in an ascending order are now completely in disorder. So this is how the shuffling algorithm works. Now let's move further and understand the next type of algorithm, which is the searching algorithm. Searching algorithm is employed to search an element in the list or array based on the type of searching mechanism used. Now for example, let's use the binary search. Now you can see a program on my screen which is an example for binary search. So we have the elements 1, 2, 3, 4 and 5 in our array. Now what we are going to do is search for the element or the key element 2 in our array using the binary search algorithm. Now let's execute this program and see the output. Now you can see the program got successfully executed and the output says the element which you are looking for is found in the index location 1. So this is how the binary search algorithm works. Now let's move further and understand the next type of algorithm, which is the composition algorithm. So the definition says the frequency and disjoint algorithms test some aspect of composition of one or more collections. So the frequency counts the number of times the specified element occurs in the specified collection. So the disjoint determines whether two collections are disjoint, that is whether they contain no element in common or not. Now to understand it in a much better way, let's go through an example. So you can see on my screen there is an example for composition. Now let's run this program and see the output. So you can see the program got successfully executed and the elements are completely disjoint. Now moving further, we will enter into our next topic, which is based on the benefits of Java collections. So there are various benefits of Java collections. Out of those, the major benefits are software or code reusability. So the Java collections enable code reusability to save time. Followed by that, the ease of designing APIs. So the next two ease of designing APIs, we have the simplicity in learning and using APIs, and finally increased speed in programming. So these were the major benefits of Java collections. What is an exception? So an exception is defined as an event that arises due to an unexpected input or logical failure in the program. This may not be considered merely as an error, but it surely does impact the normal functioning of the program segment. Now, these types of exceptions are resolved by the most efficient mechanism called exception handling. Exception handling is not any rocket science, but a simple mechanism that drives the compiler to the next statement by making the compiler understand that the input obtained or the malfunction that arises is just an unexpected or an unnecessary event which can be ignored by sending the user with a relevant message about the exception arose. For a better understanding, let us go through a small example. So as you can see on our screen, we have typed in a program. So according to this program, we are going to access a file called data.txt from the C drive. So this particular data.txt is not really existing in the C drive. So when we run this program, we will face an exception that says file is not found. So let's try to run this program and see. So as expected. So when we run this program, we get that this particular file, what you're looking for, which is data.txt, is not found. Or in other words, it is not present in the specified location. So this is how the exceptions work in Java. Now followed by this, we will move ahead into our next topic, where we will understand the meaning of an error. So what exactly is an error? So here we are trying to learn about the error just to eliminate the ambiguity between an exception and an error. Also further, we will discuss the major differences between them. But now, let us go through the term error first. Unlike an exception, an error poses a serious potential threat to the program, or sometimes it is even capable enough to collapse an entire software. So basically, an error is occurred due to syntax error or some logical error while coding. So we have a sound understanding of an exception and an error. Now let us move further and learn the differences between the both. Error versus exception. So some of the major differences between an error and an exception are: an error is classified under unchecked type, whereas on the other hand, an exception is classified under both checked and unchecked. The next difference is, if a program encounters an error, then it turns out to be completely irrecoverable until the error is resolved. Whereas in the case of an exception, if the program encounters an exception, then the program is easily recoverable. Followed by that, the third difference is, an error belongs to the package called java.lang.error. On the other hand, an exception belongs to the class java.lang.exception. The fourth difference says that an error can be encountered only during the program's runtime, whereas on the other hand, an exception can be expected both during the runtime as well as the compile time. Finally, we will mention an example for both an error and an exception. We can consider the input and output error as an example for error, and on the other hand, we can consider divide by zero exception as an example for exception. So with the differences discussed, we will now move ahead and have a look at the exception hierarchy in Java. The hierarchy of errors and exceptions is really simple. There is one root class called the throwable. Now, the throwable class is basically inherited from object which comes from the superior root called java.lang. Now, the throwable class is inherited by two child classes which are none other than the error and an exception. Further, an error is inherited by different types of errors, for example, JVM or Java Virtual Machine error, memory error, and also in some cases, some of the errors are caused by the incompatibility of the IDE or the framework which you are using. Next up is the exception. Now the exception is inherited by few more exceptions which are mentioned as below. The exceptions can be input-output exception, SQL exception, class not found exception, runtime exception, and many more. Further, the runtime exception is inherited by some more, which are the arithmetic exception, number format exception, etc. Now that we have a good understanding of the exception hierarchy, let us move ahead and check the differences between checked and unchecked exceptions. So the first one, which is the checked exceptions. These are really simple exceptions and can be defined as follows. An exception that pops up during the compile time is called as the checked exception. It is not serious and is completely ignorable. Followed by the checked exceptions, we have the unchecked exceptions. On the other hand, the unchecked exceptions are defined as an exception that pops up during the runtime is called as the unchecked exception. It is considered as serious and is caused by logical errors. So to understand checked exceptions in a much better way, we shall go through an example. So this particular example is based on checked exceptions. So basically, we have a text document called data.txt in the location documents, username, users, C drive. So this particular data file has 5 lines. So we are going to access the starting 3 lines of this particular file, and basically when we try to run this program, we will face some of the major exceptions, which are unhandled exception type input output, and again the same exception, and here file not found exception. So these exceptions are errors. So to understand checked exceptions in a much better way, we shall go through an example. So this particular code segment here is trying to read a document from C drive, which is data.txt. So this particular data.txt has 5 lines of text. So what we are going to do here is try to type in a for loop and try to read the first 3 lines of this particular document. So basically when we run this program, we will face some of the exceptions called file not found exception, input output exception, and another input output exception. So we can resolve this particular program with small modifications to the program, and then if we run this program, then we can find our lines. So the lines in the data.txt file were, hello, welcome to Simplilearn. We are an e-learning company. Our certification is recognized by major MNCs, enroll and upskill. So this particular example was for checked exceptions. Now, we will also go through an example for unchecked exceptions to learn it in a much better way. So this particular example is based on unchecked exceptions. This particular program is really simple. We have an integer type array, and inside that we have 10 elements, which are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So what we are going to do is we are going to access the 11th element of the array, which is not really present. So this should throw an exception. So array index out of bound exception is one of the examples for unchecked exceptions. So with this, we will move ahead into our next topic. Now we know what exactly are checked and unchecked exceptions. Moving further, we will slowly dive into the process of exception handling. In the process of exception handling, we have 5 major keywords. So we will learn each one of them as follows. So the first one is try keyword. The try keyword is used to specify the exception block. In a program, when you specifically type the exception that you might expect to face in your program, then you describe it using the keyword try. Followed by that, the solution for that exception will be defined in the catch block. So the catch block is used to specify the solution. Finally, the finally is a keyword which has the executable code which is completely mandatory for a program to execute. Followed by finally, we have the throw keyword. The throw keyword basically throws the exception when it is found during the runtime. Followed by that, we have the throws. The throws keyword is used to declare the exception. So basically, this is where you declare the kind of exception you are going to expect in your program. Sometimes you might try to type in your user-defined exception, or sometimes you might type in the exception that is default in its way. Or in other words, it might be system-defined. Now that we have a good understanding of the implementation of the exception handling in Java, let us move further and solve some of the most frequently faced exceptions in Java. So with this, we enter into our 7th topic, which is common exceptions faced in Java. So the first one is the array index out of bound. So if you try to store a value in an array or try to access an element in an array which has an address exceeding the array's maximum location value, then this particular exception is thrown. So to understand this particular exception, let us go through a practical example. So as you can see, on our screen we have an array of integer data type. So we are going to store the values 10, 20, 30, 40 and 50 in 5 different locations of the array, which is 0, 1, 2, 3 and 4. Now we are going to provide the address of the required element. So during that process, we are going to specify one location which is more than the maximum location of the array. So here the maximum location of the array is 4, and if we try to provide the location 5, then this program should throw us an exception. So let's try to run this program and see the output. So as you can see, we have our array here. Now, the program is requesting us to provide the address of the element required. So what if we provide 5? So now it should throw an exception. So this exception is the array index out of bound exception. Now let us try to run this program again and specify the proper address. So for this time, let's provide 4 and see if we get the output. So as you can see, at the address location, we have the element 50 as we have defined here. Now our program is running perfectly alright. Now let's move ahead into the next type of exception, which is none other than our null pointer exception. If you try to perform an operation on a null value, this particular exception is thrown. So might be a little ambiguous. To understand this particular exception in a perfect way, let us go through a practical example. So here on your screen, you can see that we have a program, and inside the program we have a string called str, which stores a text called Simplilearn. Followed by that, we have another string type which stores a null value, which is abc. As you can see, abc is equals to null. Now here we are going to access the value of abc. So here the string abc has a null value and we are trying to access it. So this particular code segment should throw an exception called null pointer exception. Now let's try to execute this code. As you can see, it has thrown an exception called the null pointer exception. So whenever in Java, if you try to access the null values, then the null pointer exception is thrown. Followed by this, we have the next type of the common exception, which is the number format. If you try to store a value with wrong formatting, then this particular exception is thrown. Now to understand this in a much better way, let us try to execute a sample program. So here on the screen, we have a sample program where we are trying to cast a string into integer. So this kind of operation should throw an exception. So as you can see, the program has been successfully compiled and we have our exception here which says number format exception. Followed by this, we have another most commonly faced exception, which is the arithmetic expression. If you try to divide a number by 0, this particular exception is thrown. Now let us go through a practical example. Now you can see we have a sample program on our screen where we have two particular numbers, n1 is equals to 0 and n2 is equals to 100. So here what we are trying to do is we are going to divide the number 100 by 0, which is practically not possible. So when we try to execute this particular program, then we should be getting an exception that says you cannot divide a number by 0. So there you have your personalized message which says the divider cannot be 0. Try a different number. So this is how the automatic exceptions work. So with this, we have come to our last topic, which is the best practices to be followed while working with exceptions in Java. So the first one is use exceptions conservatively. So exceptions have proven that they can be costly if used recklessly or unnecessarily. So it's better we use Boolean values to indicate successful implementation of smaller operations. For example, if you specify a particular operation and it successfully gets executed, then you can just notify the user by specifying a Boolean value which can be 1, or in the case of failure, you can just specify the number 0. Next after that, we have the customized exceptions. It is a very good practice of customizing your exceptions in the design time rather than planning them on the go. So in other words, we can consider this as if you're planning to design a software, then in that particular stage itself, you must also evaluate the kind of exceptions you might face on the process of designing. So tomorrow, if you completely design a software and suddenly an exception is popped in your head, then designing or including that particular exception in your finished software might be difficult. So it's better you start planning your exceptions. Followed by that, we have exception logging. Keep track of the exceptions, and this process comes handy as the user understands why exactly a particular exception has popped up. Followed by that, we have early throw and early fail. An exception should be thrown as early as possible and should be resolved in the same pace. And then we have the closing resources. Since exceptions halt the complete program, we must make sure that the system resources are shut so as to save the resources.
What is JDBC? JDBC is a tool or an application programming interface that establishes a connection between standard database and Java application that intends to use that database. Need for JDBC? Establishing database connectivity to execute MySQL or SQL queries and DDL/DML commands. View and modify data records. And one of the most important things to look at when we're talking about a JDBC, and probably the most confusing part where the devil's in the details, is data types in a JDBC. So when we start looking at the data types and you're setting up your data, you have your SQL, which is your var character, and your Java equivalent, java.language.string. And you have your bit in SQL. In Java, it's Boolean. In SQL, it's numeric, java.math.bigdecimal. Integer, int, real, float, float, float. So there's no real difference in Java between a real number and a float number. Your double is double. Your binary is a byte. Data, Java SQL date. So your date in java.sql date. And there's also your SQL timestamp, java.sql timestamp. Array, java.sql array, reference, java.sql.reference, structure, java.sql structure, character, java.language.string, big integer, long in Java, variable binary is a byte, a clob, and that's character large object, and then the equivalent is java.sql.clob, and then you have your blob in SQL, which is a collection of binary data stored as a single entity, and the equivalent in Java is going to be your java sql.blob. Now, if you're doing a lot of programming, I would suggest having a cheat sheet there, and then once you're up and running, you'll start to remember most of these just because out of use. With the JDBC architecture, we're looking at the application, then it goes into the JDBC API. So you have your application you're writing, your Java Database Connector API, then that has a manager underneath of it, and then you have your Java Database Connection drivers. And the drivers are the ones that are transferring that, whether it's an SQL server, MySQL server, the Oracle database, or different sources that use a JDBC connection. JDBC environment setup. So when we talk about the environment setup, we have Java and your environmental setup underneath of that. In setting up a Java environment, you have to download the latest JDK, set Java to home, and set your Java path. So if you're just using Eclipse for the first time or whatever IDE you're using to program, you want to make sure you have that all set up and you have the current JDK in there, the Java development package. And then with MySQL, setting up MySQL environment, download the latest MySQL workbench, extract the file, run the setup file. And that'll get you set up with your own MySQL on your computer. And MySQL registers with your operating system. So it's kind of like a global variable when you start accessing it. And it's designed that way because normally when you're using an SQL or MySQL database, it's installed on a server. So it makes sense that you want it registered with the operating system so it's accessed globally. Steps to connect your JDBC. Step 1, import your packages. This procedure is followed to make sure that the relevant packages are readily available for the API. Step 2, load and register your driver. The imported drivers needed to be loaded and registered for establishing a connection between application and database. And if you remember, in this case, we're doing the MySQL, so we make sure our MySQL driver is installed. And step 3, connecting database. After the first 2 steps, the next stage is to connect the database. This can be done by a GET connection. Step 4, writing a query. So now we're actually starting to get into your scripting. Here we write in the SQL command or query that we need to execute. If you're not familiar with SQL, it's good to have an SQL cheat sheet set up. Once you start understanding how it's put together, you'll find that it goes really quick and it's pretty fast to learn, but it is its own query language, and you do need to learn a number of the main settings and poll language so you know what you're doing. Step 5, executing query. Now the query from the API is executed using execute query, and we'll actually load that up just as a string variable. When we look at that, you'll see how that fits together. Step 6, processing result. After step 5, the system basically does 2 things. It processes an output and retrieves the values from your query. And then step 7, closing statement. The result set and statement needs to be closed explicitly. And you'll find there's 2 closing statements. There is your result set, which is still pulling from the database. And then step 8, which is we need to actually closing connection. So the last stage is to disconnect ourselves or the API from the database. So we no longer have that open connection using resources. So we're going to jump into our Java database connection example. And we're going to do that with what we call the university database. Let's start with a basic overview of MySQL. And you can go to dev.mysql.com. And you'll see here we can look up more information. They have the download of the newest version. This is a full SQL database package, and some of these you can actually go in there, and if you're doing database management, they can spread across up to, usually don't want to go more than 5 servers, but it is designed to go up to 5 servers kind of set up with terabytes of data in there. For a developer on the programming side, we usually want to install something like MySQL locally. So on my setup, it has no network connections. It doesn't auto start on the boot up of the computer, and I have it locked down. That way, if I use some kind of simple password or something like that for one of my demos, it doesn't go anywhere. No one can access it. Now, another option to MySQL is also the SQLite. And you can go to the sqlite.org, read more about it, and download it. It has a couple limitations that you're not going to see in your full-scale MySQL or Oracle or SQL, but most of it will transfer over. And so for a small project, you can actually use it as the backend for storing your data. You can also integrate it or upgrade it into MySQL, because most of the SQL commands are the same. And when you go into the MySQL, which is a significant download versus SQLite, you can certainly go down to downloads, and then there's also the connectors. So devmysql.com/download/connector/j. And I bring this up because it depends on how you've set up Eclipse for your interface and your IDE, and it depends on what you need and how exactly on your setup as far as the connectors. We'll look at that a little bit more closer. In the MySQL, it isn't Oracle based, so you'll have to set up an account if you don't have one. You have to log in. It's all free. As long as you're not doing like the enterprise with all the support and help on it, you don't have to pay for it. It's an open source. Now, once you've installed MySQL, and if you do SQLite, you're not going to have these interfaces. It'll all be done from Java code. But once you've installed MySQL, it's going to add in a terminal window, and then also the workbench, which is just a nice GUI interface for MySQL Server. And we're not going to do anything with the workbench. You can play with it certainly, because a lot of times you don't have the workbench installed on your computer, especially if the MySQL is set up on a different server and you're remote accessing it. Especially if you're in the classroom or something like that, they probably have sent you your login information so you can get into the shell. Quick note though is if you do your own MySQL, just note that I kept this as a local host. You can actually see it down here, root localhost. No outward connections, and that's just to protect my computer. Once you start opening those, you have to be aware of your passwords, and since I'm doing demos, I want to keep my passwords really simple, so that's not the focus of the programming. I had to log out and relog back in. So once you've gone in there, you should have this. A lot of times your interface might be web-based if it's a remote MySQL connection you're working with, and it'll prompt you for your username and password. In this case, mine is on my computer. It automatically has me log in as admin, so I have full admin rights. And then we always like to start by, at least I do, is show databases. And these are the current databases on here. They have some different information on them that is part of the basic setup, and some examples like Sakilla and World are both example databases that automatically load with MySQL. For this example, we're going to create a database, and it's going to be university. We'll do capital there, university. Don't forget our semicolon, and time. You can see how long it took, 0.69 seconds. And of course, if we go show databases, you'll see now that there is a university in there. And we want to go ahead and use university. That means that whatever we do, any commands that we have in here for tables or whatever are now going to be going into the university database. So now our database is changed. And let's go ahead and zoom in. Let's see, here we go. Set. Okay. A little bit more so we get the nice big print so you can see what I'm doing a little bit better. There we go. All right, so we're going to go ahead and create our table. And this has all been prepared, so I don't have to go through and redo it all the time. You'll see here we're going to do create a table engineering student, and then we have student ID as an integer, not null. Department variable character 25 long, first name, last name, pass out year, university rank, primary key. In creating this, note a couple things. First, we created a table, engineering students, and we've gone ahead and created the fields as part of the create setup here. And the things I want you to note is that we have our integer. So our student ID is an integer, our department is a variable character, and it's 25 long. And the reason I say that that is really important is when we flip back on over here, if you remember from our, there we go. If you remember from our data types, here's our variable character, and in Java language, that's a string. A string doesn't say, hey, it's only 25 long. And so you got to be a little careful when you're pushing and pulling this data, especially when you're writing the data from Java into the SQL, that you check for that length of that string. And then the integer is, of course, an integer. And of course, your other data types, you can see how they follow suit. But with variable character, be very aware of that that is a designated 25 characters long. And we're going to go ahead and insert some data in here. Here we go. We'll go ahead and insert into engineering students values. And this is going to be the student ID. And it's also the primary key. So keep in mind that that is a unique value in there. And then we have CSE, Computer Science Engineering, Karan, Akaria, 2018, 1272. So there's our pass out year, 2018, and ranked, I guess, number 1272. I'm not sure where the, oh, that's a university ranking. There we go. And then we have some prepared data, which I just went ahead and pasted in. So we have a whole bunch of individuals in our database now. And it's the same line over and over again. Insert into engineering students, values, and then you have your list of values. And we can see that by doing a simple select. We'll do, star. So it's going to select everything, one of our hot characters. If you're not familiar with SQL, get a setup on there and look it over. And you can also download a cheat sheet from somewhere with all the different commands in there. I myself do a lot of consulting, and so I'm always jumping around from one platform to another. If you're doing that kind of work, it's more important to understand the limitations and the advantages of different systems, and then you have your cheat sheets for putting together stuff really quickly when you need it. And you can see here the data we just put in there. There's our student IDs, department, first name, last name, pass out year, and university rank. And we'll go ahead and do one query in here real quick. We already did one query. We're going to do two queries. We did select star from engineering, and then we're going to go ahead and select student ID, department, first name, last name. So you can actually choose what you select instead of doing the asterisks. Where student ID equals 10202. And when we go ahead and execute that in here, oops, there we go. You'll see that it returns the one individual with that student ID here. So let's take this back into our Eclipse, because we're still doing the setup. So you have your MySQL Server setup, or you did SQLite with a little bit different setup going on there. And let's flip on over and see what's going on with Eclipse. So in Eclipse, we're going to go in new. We'll start a new project. And we'll call this JDBC. It's our JDBC project. Whoops. Select a wizard. I forgot where I was going on there. It's a Java wizard. We're looking for this project. Java project. There we go. And we're going to call this there. Now we're in the right spot. JDBC package. That way everything will be bundled in there in the same package, and finish it. Create. All right. So you can see right here we have our new JDBC package we're working with. Now at this point there's a lot going on as far as your options. If you set this up for doing database management, which I did not, and I'm going to show you the two different ways, you can go under Windows and under Preferences, and in this list you'll see database management, and then you can just go in there and set it up this way, and it'll pull in that information for your SQL connections. Now if you did not and you downloaded the MySQL, it does have an option to download the Java Connects, which would put it into wherever you installed that at, which is default under your C drive program files. Now on mine, I didn't. I downloaded the connection separately. And there's two different ways. We can go under Project, and under the Build Project, give that a moment to come up. Oops. I mean Properties. There we go. The Project Properties and the Java Build path. This same window can be accessed by right-clicking on your package we're working on, and then we can go down to Properties, and you'll see the same window opens up. And we're going to go under Java Build Path, and we're going under Library. So these are libraries we want to include in our setup. And then I click on our module path, and at this point you'll see Add External Jars here. Now again, if you have it already pre-set up in Eclipse, you can just add jars and it will be in the jar library. So there's different possibilities there. But I did a download, so I'm going to go Add External Jars. And I happen to keep mine on my D volume under my SQL. And you'll see my SQL connector Java, and this is MySQL 8.0. And I just go in here. Oops, there we go. I just go ahead and open this up, and you'll see right here it has my connector Java. Once I set that in, it's now added those packages, and there's hundreds of actual subfiles in there, and it's all set to go. And I can apply and close this window. And now I'm ready to go ahead and start writing my script and start building a program in here. And let's go ahead and go under Source, New, and we'll go ahead and put in a new class in here, and we'll just go call it JDBC. Same as the package. We'll go ahead and finish that. And we're set up with a new class in here. And once we've got this set, the first thing we want to do is we want to go ahead and import all of our Java setup in here. So we have the Java connection, and now we want to go ahead and import it. And when we look at this, we can see we have our connection. And remember, two of these have to be closed explicitly, and that's your connection and when you create the statement. You have your driver manager. So when it goes in there, that's the piece that connects to, actually does the connection to the database, the drivers that convert everything in the code in there. So you have your connection to the database, you have the code that converts it, you have your result. So you're going to get a result off of your query. Then you have your exception. So if you have an error throws or something like that, that's where that's going. And of course the actual statement that you're going to send to the SQL server. And of course we want our Java to be able to actually run, so we'll put our main in there, public static void main, and it's going to throw the SQL exception. So you'll see right here, that's what we're working with, and there's our Java SQL exception on there. So the first thing we're going to need on our setup, let's put that in here, is going to be our connection information. We need to know the username, and we're just going to call it string uname equals, in this case I created a user, Richard_Simplilearn, and then I created a password, my password. Remember, this is a local host, so you probably don't want to have a simple password like that, but this whole database is locked down on just this computer. There's no outside network access or anything like that to get in here. And then of course this is a separate user, so it's not even my admin or root user. And then we go ahead and put a query right here. In this case we'll start with our most basic query. If you remember, we already did that on our at the very beginning, select star from engineering students. And we're going to use that query in our code to start off with. And then another really common thing when you're setting this up is that we also want to test it and see, hey, did we import our package correctly? Is it set up correctly? So remember, we came in and we imported our MySQL connector jar file. In the code, we would just want to make sure it's working correctly, and that's what this is. It says try class for name, and then it has our com.mysql.cj.jdbc driver. It's saying, hey, do we have the driver for this? That's all that's doing. And if not, then it's going to print an error so we can find out why it doesn't have that driver. And then next we want to actually start getting into our actual code. And in here we're going to do a try, because whenever you do any kind of major connection, you want to make sure that you're looking for your errors. You're not going to mess on anything. And we're going to do a catch. And so we're looking for any kind of SQL exception error. And for this demo, we'll just do, print it out. So, oops, wrong spot. It goes into the catch section. There we go. So we'll print it out over down here as far as the error on there. And it's an SQL exception, so it's still looking for the code, which we haven't put in here yet. And this is really where the magic really starts to happen, because we have our connection. And there we go. And you'll see that the connection is, that's all this is right here. Here's our connection up here. And we pop it down here. We have a connection. We'll just call it con. Do one end, so keep it uniform. There we go. And this is going to go to the driver. So in other words, right here, we're going to go ahead and need the driver manager. And that's where we imported here. And it says get connection, because that's part of the driver manager. And we have our URL. Let's see, and we of course forgot to put the URL in up above. So let's go ahead and go back there and put that in. And the URL comes out as a JDBC MySQL. That is registered with my computer. So my computer has, when it's running the MySQL, this is the local host. In this case, we call it university. That's where this comes from. And that's all part of your MySQL setup. If you're working with a remote database, you'd want to get this information from the remote, whoever set the database up, so that you have this particular line of where to call. And so when we go back down here, we have our connection. It's all set up on here. The next thing we want to do is we want to go ahead and create our statement. And this initializes it. So we have a statement called statement. But this statement's going to be based on our driver manager, which is then connected to the connection. So these are all connected to each other. And this generates the format it needs for when we actually send our inquiry. Remember, here's our query right here. So we're going to send select star from engineering students for right now. We haven't put that part in. We're just creating the class or initiating the instance so that we can do that. And then once we've initiated the instance here, oops, go down here, we need to go ahead and generate a result. And so we have our result set. Again, that comes up here from what we brought in. We're storing the data coming in, or storing the pipeline to bring it in. We're just going to call that result. And then we have, this is generated from our statement. Here's our statement. So this is all like linked together. Here's our execute query, which is part of the statement. And here's the actual query, which is coming that we put together, the select star from engineering students. And then finally, we want to actually do something with our information. So what we'll do is we'll just loop through it while. And here's our result set that we just generated. So while result dot next. And this just generates a Boolean. So it says, hey, there's still another result coming in. So we need to go ahead and get that next result. And we'll go ahead and create a... and we'll take that string university data, and then we're going to loop through the different results. There we go. Integer, and then here we go, university data. And we want to tag on the end of it result.getString_I. So what's going on here? We just did a bunch of things. We are going through each row, result.next, each row of data that comes off of the database until this returns null. There's no next result coming in there. And then we come in there, we look at the result. The one we're looking at is the current one, so it goes through, I forget how many we put in there, about 20. It goes, row 20 with 0, row 1, row 2, row 3, row 4. And then on each of these rows, we have a string, and it's an array of strings. And we're going to get that string, and it returns I. So this is get string of column I. So we have row and column. And really important in today's programming to really understand rows and columns, because that's so central to most of the data processing going on. And then finally, we want to go ahead and see our results. So let's print them out. We'll put in our nice print statement, system out print line university data. So this is going to print each row as it goes through it. And then I'll reset the row again to an empty string, and then I'll add each of the columns to that row from our result, and then we'll print the next row out. And now that we have a complete code, let's go ahead and go up here, hit the run button. It's going to compile it, runs it out, and we can see down here, let me just get my double mouse so we can get a better view. Here's our different, your ID comes up. I forget what the actual setup was, but the CSE, the name, the date, the ranking, all that prints out one row at a time, and that's what we're doing here. Of course, if you're processing the data differently, you might be loading this into a user interface. This might be generating other information. You may be doing statistics with it. But you can see how it's set up in here as far as pulling the data into the Java format and then running it from there. Just so we can get a quick glimpse of where this goes, let's go back up here. And we're going to flip back and forth between a couple different screens. So let me do that. And here, if you remember, we did select star from engineering students. And there's the same thing up here that we got down here. This is our MySQL Server interface, and this is the interface we built in Java. And if you remember, we also did this particular selection, select student ID, department, first name, last name, pass out year, university rank from engineering students where student ID is. And we got the single row on here. And this is kind of interesting because I switched something in the code here where this could cause a problem. It won't on this one. Let me go ahead and paste this in here, and then we'll run and compile this one. And you see it comes out with the single user. So the danger of this particular code is that I went ahead and hard-coded in a loop for I equals 1 to 6. And so this one we pulled, it just happened to be that we selected 6 different columns in here. So you got to be a little careful when you're coding in here. What are you pulling and where is it going? You can see if I take out, let's do, we'll just remove the student ID. And we're going to run that without the student ID. Recompile it, there we go. And it gives us a bunch of errors because it doesn't see we're short a column down here. So when it gets down to this code down here, under the while statement, and it goes, hey, where's number 6? Well, there's no number 6, and so we get a lot of errors on that. And you can see where queries, let me just go back up here and paste another query in. There we go. And we'll run this one, and what we're looking at is we're going to go ahead and do the same columns, and we'll just leave this as a star to make it easy. So we're going to select all columns. From engineering students where the pass out year is 2018. Let me just do a copy of that one. And we'll run that. It recompiles. And you can see here's all the 2018 on here if you look at the dates. So they're all 2018. And that's the same as our query directly into the SQL Server. If I do the same thing on here, you'll see they're exactly the same. And just because we're having fun, let's flip this back over here and we'll do one more SQL Server. And let's do in this one, let's see, let's just take this whole thing out here. And in this one, we're going to pull in all the departments, but I want the minimal university ranking as the highest from engineering students. That way we can get an order of the rankings on here. And we'll go ahead and run this. And there we go. There's our minimal one. So this one hit the lowest ranking on there, or closest to number 1. And we can do that in here and get the same result. There's Karen. Karen is awesome. Ranking number 96. And you see all these other people that are ranked way below Karen. So this guy must be super smart. So that concludes our JDBC example, University Database, where we took a quick look at MySQL Server, or you can do SQLite, and some basic queries you can put in there and how that works.
What exactly is a servlet? Now imagine you're searching for some information on the internet. You open your local browser and start typing it. This question from you to the internet is called as request. So further, this request is sent to the cloud, or in technical terms, your browser sends your request to the respective server responsible for storing for that particular information and helps you with it when requested. Now the server gets triggered with your request, and in return, it helps you back with the information you have requested for. This answer from the server is called the response. So this is how the request and response work in a server. For this process to happen so smoothly and effectively, we need a servlet. Digging a little deep into the server, we find the component responsible for such an effective job. It is called the servlet container that holds Java-based web application and a set of individual components called as servlets. Now we are close to our answer. So this particular Java-based component takes care of web request and response. To sum it up with the form of a definition, we can define it as follows. A servlet is a Java program that runs on the Java-enabled web server or application server. They are used to handle the request obtained from the web server, process the request, produce the response, and then send a response back to the web server. Now, hoping that it was a clear explanation, can we move ahead with the next topic? So the next topic we have is, so how does the servlet work in reality, or more practically or in depth? What's the life cycle of a servlet? So the life cycle of a servlet in real time has the following stages. These stages are the ones that a Java servlet actually follows in real life to get our work done. So the stages are init, service, and the CRUD operations, which are the get, post, put, delete, and finally destroy. Now let us understand each one of them in a bit more detail. The first one is the init process. The init method is called only once. It is called only when the servlet is created and not for all the requests afterwards. So it is used for the one-time initializations, just as with the init method of applets. The servlet is normally created when a user first invokes a URL corresponding to the servlet, but you can also specify the servlet is loaded when the server first started. When a user invokes a servlet, a single instance of each servlet gets created, with each user request resulting in a new thread that is handed over to the doGet or doPost as appropriate. The init method simply creates or loads some data that will be used throughout the lifecycle of a servlet. Followed by the init method, we have the service method. So what is service method? Service method is the main method to perform the actual task. The servlet container, that is the web server, calls the service method to handle requests from the client or the browser and to write the formatted response back to the client. Each time the server receives a request from the servlet, the server spawns a new thread and calls service. The service method checks the HTTP service type and accordingly performs the CRUD operations, which are the get, post, put, delete, etc. and calls doGet, doPost, doPut, doDelete, etc. methods as appropriate. The service method is called by the container and service method invokes doGet, doPost, doPut and doDelete, etc. methods as appropriate. So you have nothing to do with service method, but you override either with doGet, doPost and other types depending on what type of request you receive from the client. So this is how the init and service methods work. Now digging a little deeper, we have the doGet, doPost, doDelete and doPut methods. So first we will discuss about doGet method. So what exactly does a doGet method do? A GET request results from a normal request from a URL or an HTML form that has no method specified, and it should be hardly by doGet method. Followed by doGet, we have doPost. A doPost request results from a HTML form that specifies list post as the method, and it should be handled by doPost method. Similar to doGet and doPost, the doPut and doDelete options are usually used to update and delete the data when asked by the client. So to sum up these doGet, doPost, doPut, doDelete, we can consider them as CRUD operations. So doGet basically gets the information what you're looking for. doPost method usually posts the information or provides you with the response from the server, and followed by that we have the doPut, which is usually used to update the data which is present on your server, and finally delete, which is used to delete an existing data on your server. So these can be considered as CRUD operations. And finally we arrive at the last method, which is the destroy method. The destroy method is called only once at the end of the life cycle of a servlet. This method gives your servlet a chance to close database connections, halt background threads, write cookie list or hit counts to the disk, and performs other such cleanup activities. So with this we finish up the life cycle of a servlet. Now we shall understand its architecture. Basically, the architecture of a servlet can be understood by reverse engineering the lifecycle of a servlet. So this is how the servlet execution takes place when a client or a browser makes a request to the web browser. So the servlet architecture includes the following. First one, servlet interface. To write a servlet, we need to implement the servlet interface. Servlet interface can be implemented directly or indirectly by extending generic servlet or HTTP servlet class. Followed by that, the next part is request handling methods. As we have discussed before, there are mainly three methods defined in servlet interface, which are init, service, and destroy. And inside service, we have doPut, doPost, doGet, and doDelete methods. The first time a servlet is invoked, the init method is called. It is called only once during the life cycle of a servlet. So we can put all your initialization code here. The service method is used for handling the client request. As the client request reaches the container, it creates a thread of servlet object, and request and response object are also created. These request and response objects are then passed as parameter to the service method, which then processes the client request. The service method in turn calls the doGet, doPost methods if the user has extended the class from HTTP servlet. And lastly, the creation of instances. This is based on the load of the servlet. So with this, we have finished the architecture of servlet. Moving further, we shall quickly discuss the features of servlets and then enter into the practical mode. So the following are the features of Java servlets. The first feature is Java servlets are portable in nature. As I have mentioned above, the servlets use Java as programming language. Since Java is a platform-independent programming language, the same holds true for servlets. For example, you can create a servlet on Windows operating system that uses Glassfish as a web server and then later run it on any operating system like Unix, Linux, and Apache Tomcat web server. This feature makes servlet portable, and this is the main advantage of servlet over CGI. We shall discuss all the differences of CGI versus servlet in the next section. For now, we will discuss the features. Followed by the first feature, we will now enter into the second feature, which says Java servlets are efficient and scalable. Once a servlet is deployed and loaded onto a web server, it can instantly start fulfilling the request of the clients. The web server invokes servlet using lightweight thread, so multiple client requests can be fulfilled by servlet at the same time using the multi-threading feature of Java. Compared to CGI, where the server has to initiate a new process for every client request, the servlet is truly efficient and scalable. The next and the final feature of Java servlets is they are robust and highly secure. By inheriting the top features of Java, such as garbage collector, exception handling, Java security manager, etc., the servlet is less prone to memory management issues and memory leaks. This makes the development of web applications in servlets secure and less error prone. So these were the important features of Java servlets. Now let us enter the practical mode. So we are in the practical mode right now. There were two parts in the practical mode. The first one was to set up the environment for Java servlets, and the second one was to execute a basic program. So this document has the following steps to follow. That is the prerequisites before executing a Java servlet program. So we have these prerequisites where we have to set up Java home and Java path. Followed by that we need to set up the home and path for JRE, which is the Java runtime environment, and finally Catalina home and path. So Catalina home and path is nothing but the Tomcat server home and path. Now we will set up these things by using the environment variables. Now I'm using a Windows operating system, so I'll be using the control panel to enter the environment variables. There you go, you have edit environment variables. So inside that just select environment variables, and inside this you can see that I have already set up the environment variables for Catalina home, Java home, and JRE home. So now let us just select Java home and edit it so that we can see how did I set it. So you can see I have named the variable name as Java home, and inside the variable value I have a location. So this location is nothing but the Java JDK location in my local system. Now followed by that we have JRE home. So similar to Java home, we have set up the JRE home as variable name is equals to JRE home, and the variable value is the location of JRE folder in my local system. So I have my JRE folder in my local system at C drive program files Java JRE, and similarly the Catalina home, which is inside my program files Apache Software Foundation and Tomcat 8.5. So similarly we'll also check out the path variables. So inside system variables you can see the path, just edit it, so then you can see the path variables set for Java, JRE, and Tomcat. Now just select OK, OK, and finally another OK. Now your prerequisites have been set up. So this is how you set them. So in case if you have doubts about the Tomcat version to download, then I'll help you with that. Just open Google and type in Tomcat download. So now you have entered Apache Tomcat official site, and Since I'm using a Windows operating system, I'll be selecting the 32-bit or 64-bit Windows Service Installer version. And after this gets downloaded, you need to set up the home and path variables for Catalina server. So once after the environment is set up, you need to follow 4 stages to create a servlet program, which are creating a dynamic web project, create a servlet, add servlet API jar file, and run the servlet. So to create a dynamic web project, you need to select new, and inside that you have the option of other. Just select other, and inside that you'll be finding web. So select web, and inside that you need to select the dynamic web project and select next. So you just need to name to your dynamic web project. So I'll be naming as server, then select next, and inside that you have a source folder, and now you can select finish. Now there you go. Java Eclipse will ask you for opening this particular in Java EE perspective. Then just select open perspective. Now basically Java will set up everything you need here. And there you go. You can see server folder here, which has already set up everything you need. Now what you need to do is set up a new servlet. So right click this and select new, and inside that you can see the option of servlet. Just select it. Now you can see a new dialog box, and here you need to set up the class name. For now, let's just type in hello and go to next. Now again next, and in here you have a lot of options. So for now we are just executing a basic program, so let's just select do get method. Now let's just finish it, and there you go. Your servlet has been ready. So this is the basic template created by Eclipse for you. Now next we need to add in the build path. So for that you need to right click the server and then select build path, and here configure build path. From here you can add the external libraries. Select the external libraries option, and you can see I have the Tomcat libraries here. Just select all and open. And that's how you add all the required libraries of Tomcat server. Now apply and close. Now the last step is to execute the project. Now just to save time, I have already typed in the program, which is over here. Now let's try to execute this. This program will just provide us a simple output, which is none other than hello world. Now the server I have chosen is Tomcat server. Let's finish it. So there you go. The message has been displayed successfully. Hello, welcome to Simplilearn. Now we'll move ahead with our next topic. Now that we are done with the environment setup and the basic example, let us now discuss the advantages and disadvantages of using Java servlets. So first, we will discuss the advantages. The following are the advantages of using servlets in Java. Servlet is convenient in modifying regular HTML. We can write the servlet code into JSP. Servlets include the feature of multi-threading of Java. We can make use of exception handling of Java. Servlets have a separate layer for business logic in the application. And finally, it is easy for developers to show and process the information. So these were the advantages of using servlets in Java. Moving ahead, we will discuss the disadvantages of using servlets. So following are the disadvantages of using servlets in Java. Designing a servlet is considered as a little complicated. Servlets often slow down the application. Business logic of servlet is difficult to understand. We need a JRE, which is the Java Runtime Environment, on the server to run our servlets. And finally, the data connectivity is a little complicated. So these were the major disadvantages of using servlets in Java. Moving ahead, we will understand CGI. Why are we learning CGI? Because even CGI is similar to servlets, and it also does the web interactive job similar to servlets. So thought you should know about some basics of it. So let's understand its definition and architecture real quick. So the CGI, or Common Gateway Interface, is a standard for writing programs that can interact through a web server with a client running on web browser. These programs allow a web developer to deliver dynamic information, usually in the form of an HTML, via the browser. A CGI program can be written in any language including Java that can be executed by your web server. CGI programs are commonly used to add search engines, guestbook applications, database query engines, interactive user forums, and other interactive applications to websites. In very basic terms, a CGI program must interpret the information sent to it, process the information in the same way, and generate response that will be sent back to the client. Most of the input of CGI program is passed into through environment variables. So with this, we will move ahead into the architecture of Common Gateway Interface. So you can see the architecture of Common Gateway Interface is completely similar to Servlet. Normally, the request is sent in the form of an HTTP request. So this particular HTTP request is divided amongst the CGI shells, and it will be processed by the CGI shells based on the program provided, and the response is sent to the user. Now moving ahead, we shall understand the differences between the Common Gateway Interfaces and the Servlet. So the first difference is the Common Gateway Interface scripts are executable codes written in native operating system, while on the other hand, the servlets are written and run using the Java virtual machine. The next difference is the Common Gateway Interface performance is considered to be low compared to servlets. On the other hand, servlets are having high performance compared to CGIs. The third difference is for a Common Gateway Interface, it is hard to switch between different platforms, that is the operating system platforms. When we come into servlets, the servlets are considered to be completely platform independent. Followed by that, the Common Gateway Interface scripts are directly executed. So on the other hand, servlets are translated into bytecode because the servlets are executed using the Java virtual machine. And in Java virtual machine, whatever the code you transfer, it will be converted into bytecode first, then executed. And the last difference is the Common Gateway Interface is not portable. And on the other hand, we have the Java servlets to be completely portable. So these are the major differences between the Common Gateway Interface and Java servlets. Now let us understand the Java servlets requests and responses. So first we will deal with the request phase. In request we have various types. The first one is being the HTTP request. The HTTP object is used to represent the HTTP request to a browser that the user sends to the web application. Thus, anything the browser sends is accessible through the HTTP request. Followed by the HTTP request, we have the request parameter. The request parameters are the parameters that are sent from the web browser along with the request. The request parameters are typically sent as a part of the URL or as a part of the body of an HTTP request. Followed by the request parameter, we have the request header. The request headers are the name value pairs sent by the browser along with the HTTP request. The request headers contain the information about the web browser software being used, what type of files that the web browser can receive, etc. Followed by the request header, we have the input stream. If the browser sends an HTTP post request, request parameters and other potential data is sent to the server in the HTTP request body, it doesn't have the request parameters that is sent in HTTP request body. It could be pretty much as the data like file or SOAP request. The next one is a request session. The session object can hold information about a given user between the requests. So if we have set an object into the session object during one request, it will be available for you to read during any subsequent request within the same session time scope. Followed by the request session, we have the servlet context. The servlet context contains the metadata related to the application. Followed by servlet context, we will enter the response phase. In the response phase, we will deal with the first one, which is the HTTP response. The HTTP response object is used to represent the HTTP response to your request. A web application sends back a response page to the user as a response to the HTTP request from the browser sent to your web application. Followed by the HTTP response, we have the write HTML. To initiate the process of sending the HTML back to the browser, you need to retrieve the print writer from the HTTP response object. This can be done using the write HTML. Followed by the write HTML, we have the response header. Similar to HTTP request, the HTTP response includes headers as well. These are responsible for all the data written in the response. Followed by response header, we have content type. The content type header is responsible to tell the browser about the type of content you are sending in the return. Followed by content type, we have the content length. The content length header is responsible for telling you about the number of bytes your servlet is sending you in return. Followed by content length, we have redirection. Redirecting will help you to redirect yourself to the different web page from the current one. So these were the HTTP requests and responses in Java servlets. Now we will enter the next part where we will deal with the session tracking and cookies. So first, we will understand session tracking. Session simply means a particular time of interval. Session tracking is a way to maintain state or data belonging to a user. It is also known as session management in servlets. HTTP protocol is stateless, so we need to maintain state using session tracking techniques. Each time the user requests to the server treats the request as a new request. So we need to maintain the state of a user to recognize a particular user. You can understand this in a better way by looking at the picture showed on the presentation. Each time you send a request, you will be receiving a response from the server, as well as this particular request will be recorded as a state in order to recognize you as a particular user. Now after session tracking, we will enter into cookies. Cookie is a small piece of information that is persisted between multiple client requests. A cookie has a name, a single value, and optional attributes such as comment, path and domain qualifiers, a maximum age, and a version number. By default, each request is considered as a new request. In cookie technique, we add a cookie with response from the servlet. So cookie is stored in cache of a browser. After that, if the request is sent by the user, the cookie is added with a request by default. Thus, we recognize the user as an old user. There are two types of cookies. They are non-persistent cookie and persistent cookie. Let's understand non-persistent cookie first. A non-persistent cookie is valid for a single session only. It is removed each time when the user closes the browser. Now let us understand the persistent cookie. The persistent cookie is valid for multiple sessions. It is not removed each time when the user closes the browser. It is only removed when the user logs out or signs out from the browser. So before we begin with what exactly is a Java API, we will understand what Java is. So basically, Java consists of two major components that are Java Runtime Environment and Java Development Kit. So when we get into Java's API, we might want to dig a little deep into Java's Development Kit. So JDK consists of three more major components that are the Java's compiler, Java Virtual Machine, and APIs. Now we will learn each one of them in a bit more detailed way. So at first we have the Java's compiler. So Java compiler can be defined as a software program that is designed to convert the high level, that is the user return or user readable code, into the computer readable code, that is the machine level or byte code. So this particular byte code will be transferred to the next state where we find the JVM. So what is JVM? So JVM is an abbreviation for Java's Virtual Machine. So Java's Virtual Machine is responsible for processing all the bytecodes and providing an output to the user. Next, we find our topic for today's discussion, that is the Java API. So just like Java's virtual machine and compiler, Java's APIs are the integral software packages that come with the JDK. The primary intention of API is to establish communications between different applications. So on my screen you can see a pictorial representation of Java API's architecture. So at first we have the Java's program on the topmost layer. So this particular segment will be having the user return program in user language. Followed by that, we have the interpreter, Java's API, and the Java's virtual machine, which are responsible for reading and compiling the Java's program. So at the last final level, we have the application hardware, which is responsible for interacting to the Java's program. So this is how the Java API's architecture looks like. Now followed by this, let's dive into the next topic. So in the next topic, we find the types of developers using various types of APIs for different jobs. So at first we have the open developers, next we have the internal developers, and at last we have the partner developers. Don't worry, we will understand each of these developers in a bit more detail and along with some examples for a better understanding. So at first we have the open developers. So open developers are used by top-end companies. So leading companies provide access to their APIs as open source through authentication via a unique secret key to keep track and ensure the legal usage. So basically what happens here is there might be some big companies like social media companies or some more other companies which provide the API they use for their applications as open source to the developers. So these open developers get access to their APIs through getting authentication. So they'll be creating a profile, they'll be providing the research details of their application, like what are they using that particular API for and other reasons to use those APIs. Then they get the unique secret key from the owner of that API, and that's done just to keep track that the API provided is not misused. So the open developers majorly include the B2C teams, and some of the major companies that provide the APIs for open developers are Twitter and Telnix. So one best example is the Twitter, where the Twitter provides Twitter API for the Twitter developer accounts for using that for any kind of developing things or some data science applications and much more. So followed by the open developers, next we have the internal developers. So you can consider internal developers as an organization. So the internal developers belong to a specific organization and work in a closed environment. These APIs run with a high security that can establish communication between the application and the application hardware. So only the internal developers, that is the developers belonging to that particular organization, have the access to that particular API. So this particular type of APIs run on a high security level. So internal developers majorly include B2C teams, B2B teams, A2A teams, and B2E teams. So some of the major companies that provide the internal APIs are Instagram, Google Mail, and Google Cloud Virtual Machines. Next we have the partner APIs. So the partner developers are similar or like internal developers, but the only difference is there is a collaboration between two or multiple companies. For example, consider yourself to be linked with a different company and you both wanted to create an application. So only you both can have access to that particular API that you're using to create your application. So partner developers majorly use the B2C teams, and the major companies providing the partner APIs are Microsoft and Finextra. So with this we finish the first topic, that was what is API and who exactly uses it and for what purposes. Now we dive into the next segment where we learn the need for Java APIs. So why exactly we need Java APIs? Now Java APIs are used for multiple reasons. But the three most important reasons for which we use Java APIs are to streamline the operations, improvise the businesses, and finally create some powerful applications. We will discuss each one of them in a bit more detail. So the first one is to streamline operating procedures. We have multiple social media applications like Twitter, Facebook, WhatsApp, etc. Followed by that we have multiple delivery applications such as Amazon, Flipkart. Then we have the F&B such as Zomato, Swiggy, etc. So all these applications are running smooth and hassle-free because of the significant improvement in the implementation of Java APIs. By using Java's APIs, users are provided with multiple options on the screen. So this kind of approach makes the functionality very simple and easy to use. Followed by this, the next important requirement is to improvise the business. Introducing APIs to the public leads many companies to release private data to generate new ideas, fixing existing bugs, and receive new ways to improvise operations. The Twitter developer account is an example for API that gives programmers private API keys to access Twitter data and develop applications. Followed by that we have the third one, which is to create the powerful applications. Online banking has changed the industry forever. and APIs offer the customized ability to manage their finances digitally with complete simplicity. So this is made possible only by the use of APIs. Now followed by this, we will dive into the next topic where we understand the types of Java APIs. So basically there are 4 different types of APIs in Java. They are public, private, partner, and composite. We will discuss each one of these APIs in a bit more detail. At first, we will deal with the public API. So what are public APIs? Public means open. So public or open APIs are Java's APIs that come with the JDK, and they do not have any strict restrictions about how developers use them. So followed by the public APIs, we have the private APIs. So the private or internal APIs are developed for a specific organization. These particular APIs will be accessible through the authentication by only the employees belonging to that particular organization. So followed by private APIs, we have the partner APIs. So similar to private APIs, even partner APIs are having some authentication process to use. So the only difference is here, instead of one organization, we might have 2 or multiple organizations, and the employees belonging to that particular group of organizations will be able to access the APIs and implement them or use them. Followed by partner APIs, we have the last one, which is the composite API. Composite APIs are microservices, and developers build them by combining several service APIs. Now that we have covered the different types of APIs, let us now discuss the categorization of Java APIs based on the services that different varieties of APIs in Java provide. So data and API services are another way to categorize Java APIs other than the previous type, which is the public, private, partner, and composite. APIs are also classified based on their data manipulation capabilities and the variety of services they offer. So this type of categorization has 4 different types, which are the internal API services, external API services, CRUD operations, and user interface services. We will understand each one of them in a bit more detail. At first, we will understand internal API services. Internal API services are developed to offer organizations services specific to that particular organizations. These services include only complex data operations and internal processes. Followed by internal API, we have the external API. External API are open source APIs that developers integrate into existing application or website. So internal APIs are something similar to private APIs, and external APIs are something similar to public APIs. Next, we have the CRUD operations. So CRUD APIs provide data manipulation operations over various data storage units such as software and service, that is SaaS, and relational database management systems such as RDBMS, using standard data storage unit connecting tools like database connectivity, that is JDBC, etc. Next, we have the user interface services. User interface service APIs are open source APIs that allow developers to build user interfaces for mobile devices, computers, and electronics. Now let's examine the rules and protocols that Java APIs must follow. So that brings us to API service protocols. The rules and protocols guide the different functionalities of Java APIs. So different APIs have different service protocols. Let's consider an example for RESTful API service protocol as an example. So for a typical RESTful API, developers must follow the following rules. For a typical RESTful API, developers must follow these rules: stateless, uniform interface, client server, cache, layer. No worries, we will discuss each one of these protocols in detail. First, we will discuss stateless. So what exactly is stateless? So since the RESTful API follows client-server architecture by default, it is recommended that RESTful API services to be stateless all the time. Next, we have the uniform interface. The entities in a RESTful API are server and clients. Applications that run on global scale need uniform client and server interface through Hypertext Transfer Protocol or HTTP, and Uniform Resource Identifiers URI will allocate the required resources. Next, we have the client server. The client-server model used in the RESTful API should be fault-tolerant. Both the client and server are expected to operate independently. The changes made at the client end should not affect the server, and vice versa. Next, we have the cache. Including a cache memory allows the application to record intermediate responses and run faster in real time. A RESTful API also includes the cache memory. And next, we have the layer. A RESTful API is built using layers. Layers of API are loosely coupled or independent from each other. Each layer contributes a different level of hierarchy and also supports encapsulation. Next, we will go through some frequently used APIs. So this is the list of most frequently used APIs in real time. So we have Web API, Facebook 4J, Twitter 4J, Android API, Java Advanced Imaging, Java Data Objects, and you can also see the acronyms for them in the right column. So some of them have no acronyms and some of them have acronyms. For example, we have Android API as Google, Java Advanced Imaging as JAI, Data Objects as JDO, etc. So moving into the next slide, we have a few more APIs. So we have RESTful APIs, Java Media Frameworks, Java Persistent APIs, Java Speech API, Java 3D, Java USB for Windows, etc. And similarly on the right column we have their acronyms. So for Java Media Frameworks we have JMF, for RESTful APIs we have nothing. And Java 3D we have J3D, Java Speech API as JS API, and few others. So followed by this we will advance into the next topic where we will discuss about the advantages of using Java's APIs. Now using Java's APIs will help you with multiple advantages. Now we will discuss the most important advantages of using Java's APIs. So the first one, we have the extensive SQL support. APIs in Java enable a wide range of SQL support services in users' applications through a component-based interface. Next, we have applications. APIs in Java provide effortless access to all of an application's major software components and easily deliver services. Next, we have efficiency. Java's APIs are highly efficient because they enable rapid application development. Also, the data that the application generates is always available online. Next, we have the automation. API allows computers to automatically upload, download, update, and delete data automatically without human interaction. Followed by that, we have integration. Java APIs can integrate to any application and website and provide a fluidic experience with dynamic data delivery. Followed by that, we have scope. Java's APIs make websites, application, and information available to a wide range of users and audience. Followed by that, we have customization. Java APIs enable developers and businesses to build applications that personalize user interface and data. And finally, we have the adaptability. Java APIs are highly flexible and adaptable because they can easily accept feature updates and change to frameworks and operating systems. What exactly is Java Enterprise Edition? The Java EE stands for Java Enterprise Edition, which was earlier known as J2EE and is currently known as Jarkataka EE. The Java Enterprise Edition provides a platform for developers with enterprise features such as distributed computing and web services. Now let's move further and understand why exactly we needed Java Enterprise Edition. We needed Java Enterprise Edition for 4 major reasons: to have powerful API support, to reduce development time, to reduce application complexity, and finally to improve the application performance. So followed by the need for Java Enterprise Edition, we will move ahead and understand the Java Enterprise specifications. So in the Java Enterprise specifications, we are going to discuss the 4 major specifications used by enterprise developers. So the first one being the enterprise specification, followed by that we have a web specification, then we have web server specification, and finally some other miscellaneous specifications. We shall discuss each one of them in detail. Firstly, we will move ahead with enterprise specification. So in enterprise specification, we have the first one to discuss, that is the context dependency injection. The context dependency injection provides a container to inject dependencies as in swing. Next we have Java Enterprise Java Bean. The enterprise Java Bean is a set of lightweight APIs that an object container possesses in order to provide transactions, remote procedure calls, and concurrency control. Followed by Java Bean, we have Java Persistent APIs. So the Java Persistent API are the specifications of object relational mapping between relational database tables and Java classes. Next, we have the Java Transaction API. It consists of Java interfaces and annotations to establish interaction between Java transaction support offered by Java Enterprise Edition. The APIs in the abstract from low-level detail to the interfaces are also considered as low-level. Followed by Java Transaction API, we have the Java Servlet. The Java Servlet specifications define how you can manage HTTP requests either in a synchronous or asynchronous way. So followed by Java Transaction API, which is one of the enterprise specifications, we will move ahead into the Java Web specifications. So the first one in the Java Web specification is the Java Servlet. So this specification defines how you can manage the HTTP request either in a synchronous or asynchronous way. It is low level and other specifications completely depend on it. So followed by Java Servlet, we have the Java WebSocket. So the Java WebSocket is a computer communication protocol, and this API provides a set of APIs to facilitate WebSocket connections. Followed by WebSocket, we have the Java Server Faces. So the Java Server Faces is a service which helps in building graphical user interface out of the components. So followed by Java Server Faces, we have the Unified Expression Language. The Unified Expression Language is a simple language which was designed to facilitate web application developers. So followed by the web specification, now we will enter the web service specification, out of which we have the first one, which is the RESTful Web Service. So the Java RESTful API Web Service provides services having representational state transfer schema. Next, we have the JSON processing. Java API for JSON processing is a set of specifications to manage the information provided in a JSON format. Followed by JSON processing, we have JSON binding. So the Java API for JSON binding is a set of specifications that provide for binding or parsing a JSON file into Java classes. Next, we have the XML binding. So XML binding simply allows for binding of XML into Java objects. For example, SOAP is an XML-based protocol to access web services over HTTP. This API allows you to create SOAP web services. So followed by the web service specifications of Java Enterprise Edition, we finally enter into the other miscellaneous specifications of Java Enterprise Edition. So out of that, the first one is the validation. So the validation package consists of various interfaces and annotations for declarative validation support offered by Bean Validation API in Java. Followed by validation, we have the batch applications. So the batch applications provide the means to run long-running background tasks which involve large volume of data and which need to be periodically executed. Followed by batch applications, we have Java Enterprise Connector Architecture. So the Java Enterprise Edition connector is a Java-based technological solution for connecting Java service to enterprise information system. So with this, we will enter into our next step where we will learn the system requirements to install Java Enterprise Edition. So the basic requirements to install Java Enterprise Edition into your local system are: you should be having the Java virtual machine from the standard 6th edition or more. Followed by that, your local system should be having at least 1 GB of RAM capacity. Next, your system should be having at least 250 GB ROM space available. And finally, you should be having the Java Development Kit installed into your local system. Now next, we will understand how to install Java Enterprise Edition into your local system. So in short, these are the steps you need to follow to install Java Enterprise Edition into your local system. First, you need to browse into the Oracle official Java site, then go to Java Standard Edition Development Kit. Followed by that, accept the license terms, download the JDK file, run the JDK file as an administrator in your local system, then set up the Java environment. I know this looks a little bit complex, but don't worry, I will drop a link in the description box below which will explain you in a much detailed way how to install Java into your local system. Please check that to have a better understanding of how to install and set up Java in your local system. So followed by this, we will learn the differences between the Java Standard Edition and Java Enterprise Edition. So the first difference between the Standard Edition and the Enterprise Edition is the Standard Edition provides basic functionalities like defining classes and objects, whereas Java Enterprise Edition mainly focuses on high-end and corporate type of Java applications. The second difference between the both is Java Standard Edition comes with only the standard specifications which will be used by a beginner. And similarly, on the other hand, Java Enterprise Edition comes with some advanced specifications which support web applications and servlets. The third difference between the both is the Java Standard Edition comes with features like class, libraries and deployment environments, whereas the Java Enterprise Edition has structured application with the client's business and enterprise layers. The fourth difference between the both is the Java Standard Edition is used for desktop and mobile application developments, whereas on the other hand, the Java Enterprise Edition is used mainly for development of web applications. The fifth difference between the both is the Java Standard Edition is preferred and used by beginners. And on the other hand, the Java Enterprise Edition is preferred and used by experts in Java field. The sixth difference between the both is the Java Standard Edition does not have authentication, whereas on the other hand, there are strict rules and regulations to be followed when using Java Enterprise Edition related to authentication.
What is JUnit? JUnit is an open source unit testing framework for Java. Here, the term unit testing framework comes into consideration. So before moving forth, let's check what is meant by the term unit testing. Unit testing, as the name suggests, is a way of testing a unit. Here, a unit refers to the smallest piece of code that can be fetched out of the system. It can be a line of code, a method, or a class. Keep in mind, smaller the chunk of code, the better it is. If the tested units are small, the tests tend to run faster, providing a better insight into the code and its performance. Unit testing helps in the early identification of defects. It enables the developers to spend more time on reading the code rather than writing it. And a successful code helps in boosting the confidence of the developer. Then coming back to JUnit, the framework is used by Java developers to create and test their codes. It is used for unit testing of the source code, and JUnit works on the approach of testing a small part, then coding that, and continuing the same till the end. JUnit testing helps developers to develop more reliable, readable, and a bug-free code. Every time a new code is added, all the test cases have to be re-executed to make sure that nothing is broken. There are graphs in JUnit that show the progress of the test. The graphs show green when the test runs smoothly and it turns red when the test fails. Now, when we know about JUnit, let's see the way to download and install that into our system. Before you go on to install JUnit, make sure you have JDK and Eclipse installed in your computer system. So, let's go on. First, open your browser. In the browser, type download JUnit. In download JUnit, we'll get about JUnit. In about JUnit, when we scroll, we find download and install. In download and install, when we go inside that link, we will find two jar files. Here, let's download these two jar files. When we click on this download button, we will download jar. After the first jar is downloaded, let's go back to that page and download the second jar file. After both the jar files are downloaded, let's go to the location. Here we can see two of our jar files are downloaded. Let's copy these jar files, go to our documents, and here in the Java libraries, where all the Java libraries are stored, let's paste them. After we have pasted these files, we shall open our Eclipse . As soon as our Eclipse opens, we will first create a project. Here, new, then we shall create a Java project. In Java project, let's name it JUnit Installation. Click on Next and Finish. Here, then in this Java project, right click on it and go to the Build Path option. In the Build Path option, go to Configure Build Path. Here, go to the tab Libraries, and this side, go to Add External Jars. In Add External Jars, you will get the location of our two jar files, and if you don't get them, you can browse to the location where you have stored them or to the location of Java libraries. Then select these two files and open them. You will see the two jar files appear here. Then click on Apply and Close. Now come back to JUnit Installation, that is a project, right click on it and click on Refresh. Then right click on the src folder, go to New and create a package. Let's name the package to be JUnit Install and click on Finish. In this package, create a new class and we shall name the class JUnit Install and click on Finish. Now let's create a method over here. In the method, we shall type public void my JUnit install then system.out.println welcome to my JUnit testing. Now I will add a library over here, library test. I can see an error. Now when I hover over this library, I can see it says import test. So now when I click on it, the error is gone. Now we shall run our test, and since we are testing with JUnit, we shall click here, go on, run as JUnit test. Here we shall click on OK, and then we can see in the console it shows welcome to my JUnit testing, as we had placed it over here. Here on the left side, you can see the JUnit report. You can see runs 1 out of 1 and there is no or 0 errors, and same there are 0 failures. So here in the space provided, you can have as many number of tests, as many bunch of code you want, and with the help of JUnit, you can test any particular part of the code.
At first, we will start with the beginner level interview questions. So in the beginner level interview questions, the first question we have is, what is JIT? So the answer for this question is, JIT is an abbreviation for Java In-Time Compiler. It increases efficiency of the interpreter by compiling the bytecode in the runtime. JIT, or Just-in-Time Compiler, compiles code to machine level directly for higher speeds of code execution. So basically, just-in-time compilation is a feature added to the interpreter of Java. So this involves conversion of the code directly to machine level during the compilation stage. This improvises the speed of execution of a Java program. Now, after the first question, the second question in the docket is, what is a class loader? Now let's discuss the answer for this particular question. So basically, class loader is the first file to load when you execute any Java program. So the Java class loader is the integrated part of Java virtual machine. So the functionality of class loader is to load the class to the Java virtual machine while it is demanded to execute a class. Java has Bootstrap extension and application type of class loaders. So the third question in the docket is, what are the memory allocations available in Java? So the answer for this particular question is, Java provides multiple types of memory allocations. But the 5 major types of memory allocations which are most frequently used are class memory, heap memory, stack memory, program counter memory, native method stack memory. So the next question in the list is, will the program run if I write static public void main? So basically we write public static void main, but in case, imagine if I write the program as static public void main, will the program execute properly? So the answer for this question is yes, because Java does not follow any specific rule for the order of specifiers you place in your program. So when you execute the program with such pattern in your specifiers, then the program will compile successfully. Also, it will run successfully. So the next question we have is, what is the default value stored in local variables? So in C programming language, when you declare a local variable or a global variable or any type of variable, then the first value which is stored inside that variable will be a garbage value, unless you initialize the variable with a personalized value. For example, if you declare a variable I equal to 0, then you are storing a value in that variable I, that is 0. If you just declare it as int I, then the value stored inside that I variable will be a garbage value. So similarly, when you declare some kind of local variable in Java, then what will be the default value stored inside it? So the answer for this question is neither the local variables or the global variables or any primitives or any object references do not have any kind of default value stored in them. So followed by the fifth question, we have the sixth question. So what would be the output of the following code segment is the sixth question. So this might happen sometimes. So basically what happens is your interviewer will throw a question at you which has a code segment. So all you need to do is decode that code in your mind and provide the output. So this would be the code that we will be dealing with. So you can see our question has two printf statements. The first one has 100 plus 100 plus a string which is Simplilearn. And in the second printf statement, we have a string that is e-learning company plus 100 plus 100. So what will be the output of these two printf statements? So the answer for this question is really simple. So we'll be having 200 Simplilearn as the first output and e-learning company 100 as the second output. Why? Let's check out the code segment once again. So when you see the code segment once again, so the first printf statement has 100 plus Simplilearn. So JVM here understands 100 as an integer value and the plus symbol as an addition operator here. So followed by the addition operator, we have another integer value. So what JVM does is it adds the two numbers 100 plus 100. So followed by that we have another plus symbol here. So followed by the plus symbol we have a string value. So here the JVM considers the plus symbol as a concatenating operator but not as an addition operator. So that's why the first two numbers got added and the result was 200 and the next two values were concatenated. So it became as 200 Simplilearn. Similarly, in the second printf statement, the JVM encountered with a string value. So it considered the plus symbol as a concatenating operator. Similarly, it happened with the second plus symbol as well. So that's the reason we had e-learning 100 as the second output. Now followed by the sixth question, we have the seventh question. What is an association? So the answer for this question is, an association can be defined as a relationship that has no ownership over the other. So to understand this definition, we can consider a simple example. Consider a person associated with multiple banks. So consider person X who has got accounts in bank A, bank B and bank C. And similarly, a bank is associated with person X. That is, a bank A, bank B and bank C are associated with the person X, but no one has ownership over the other. A person X who is an account holder with all the three banks, that is A, B and C, does not possess any kind of ownership over the three banks. Similarly, banks A, B and C who has the customer, which is the person X, but the banks do not possess any kind of ownership over the customer. So the relationship between the person X and the banks ABC can be considered as an association. Now followed by the seventh question, we have the next question, that is the eighth question. Define copy constructor in Java. So the answer for this question is as follows. A copy constructor in Java is a constructor that initializes an object through another object of the same class. A copy constructor in Java is really helpful because when you want to copy a complex object that has several fields, or when we want to make a deep copy of an existing object, then the copy constructor is the one which will help you out in this situation. So followed by the eighth question, we have the ninth question. What is a marker interface? So the answer for this question is, an empty interface in Java is referred as a marker interface. Serializable and clonable are some of the popular examples of marker interface. So basically a marker interface is just another interface, but normally in interface we provide some signatures. So these signatures belong to particular methods. So in normal interface we just have method signatures, but not the complete implementation, or at least we'll be having some variables. But in a marker interface, we do not have any kind of data manipulating method signatures, any data members, nothing. They have special functionality unlike a normal interface. So followed by the ninth question, we have the 10th question. What is object cloning? I guess the word object cloning is completely self-explanatory. Yet the answer for this question is, it is an ability to recreate an object completely similar to the existing object. This process is known as object cloning in Java. Java provides a built-in function or method, that is the clone method, to clone an existing object, offering the same functionality that of the original object. So followed by the 10th question, we have our 11th question. Why is Java not completely object-oriented? So this question might be a little confusing, but it's true. Java is not completely object-oriented. But what's the reason? Yes, I'll explain you why Java is not completely object-oriented. So the answer for this question is, Java is not considered as 100% object-oriented programming language because of the data types it uses. It still makes use of 8 or more primitive data types, which are int, float, double and few others. So this is the only reason why Java is not considered as completely 100% object-oriented programming language. So the next question is, define wrapper classes in Java. So the answer for this question is, in Java, when you declare primitive data types, that is the int, float, double, etc., then the wrapper classes are responsible for converting them into objects or reference types. Just as we discussed before, Java is not 100% object-oriented programming language just because of the primitive data types it uses. So when you include such primitive data types, then wrapper classes are the ones which convert them into objects or reference types for the ease of compilation and execution of programs without any issues. So followed by this question, we have the next question. define singleton classes in Java? So the answer for this question is, in Java, when you make the constructor of a class as private, then the particular class can generate only one single object. This is the reason why such type of classes are called as singleton classes. So followed by that, we have our next question that says define package in Java. So if you use some of the popular IDEs, that is the integrated development enterprises such as IntelliJ or Eclipse, then you might be familiar with projects, packages, source files, and then the class file. So basically you create a project first, and inside the project you will be having your source folder, and then you will be creating your own package using the source folder, and inside the package you will create a class file, and inside the class file is where you write your Java program. So here the question is, define package in Java. So the answer for this question is as follows. Package is a collective bundle of classes and interfaces along with necessary libraries and jar files. The use of packages helps in code reusability. So basically when you create a specific package, inside that package you will store all the class files that you will be using in your Java program. So not only class files, in case if you use any kind of connectors or any kind of jar files or any kind of dependencies for your Java program, you will include all those inside the package so that the requirements and the class files are bundled together, and this helps out in code reusability, making sure that the program files or the jar files or any dependencies are not juggling between one package to the other or one file to the other. So using a package is basically a good practice. So followed by this, we have our next question. Can you implement pointers in Java program? So if you remember C programming language, we had pointers there. So we use pointers to directly access the memory. So similarly, can you use pointers in a Java program? This is a little tricky question for beginners, but basically it's really simple. Now the answer for this question is no, because Java Virtual Machine personally takes care of memory management implicitly. So Java's major motto was to keep programming simple. So accessing memory directly through pointers is not a recommended action. So the answer is a big no, you cannot implement pointers in Java program. So followed by that, we have our next question. Differentiate between instance and local variables. So the answer for this question is really simple. Instance variables are declared inside a class and the scope is limited to only a specific object inside which an instance variable is created. So followed by the instance variable, we have the local variable. So the local variable can be anywhere inside a method or a specific block of code. Also, the scope is limited to the block of code where the variable, that is the local variable, is declared. Now followed by the 16th question, we have our next question. Explain Java string pool. So the answer for this question is a collection of strings in Java's heap memory is referred as Java's string pool. So for example, you wanted to create a new string. Consider your name. So your name might be some XYZ. So if you wanted to create XYZ string, then you provide that particular code to your JVM. So what does JVM do? It will not directly create that particular string. First, it will search for the XYZ string in your string pool. If that is already existing in your string pool, then it will provide a reference to that particular string. In case if XYZ is not there, then the JVM will create a new string, that is the XYZ string. So followed by this, we have our next question, that is, what is an exception? So the answer for this question is, an exception in Java is considered as an unexpected event that can disrupt the normal flow of the program. So for example, just consider that you are going to write a program for division operator. So after you finish your program, your evaluator might want to test your code to the extreme levels. So instead of providing a proper number, imagine that your evaluator is providing a wrong input, such as special symbols, sometimes 0, or any other sort of input. So if this kind of input is provided to your program, then your program might crash. So you can avoid this kind of crash by using exception handling. So basically you can use try and catch blocks. So you can embed your code inside the try block and say to your program that if any kind of wrong input such as special symbol or 0 is provided by the evaluator, then send a message saying wrong input or divide by 0 exception. So this kind of approach will provide an output, but this kind of approach will avoid your program from crashing. So this is how exceptions are handled in real time. So followed by this, we have our next question. What is final keyword in Java? So the answer for this question is, the term final is a predefined word in Java that is used while declaring values to variables. When a value is declared using the final keyword, then that particular value of that particular variable will remain constant throughout the execution of program. So sometimes if you include a normal variable and provide an operation on that particular variable, then the value of that particular variable will change after the execution of program. But when you declare the same variable using final keyword, then no number of operations or any kind of manipulations applied onto that variable will not change the value of that particular variable. So that's the speciality of final keyword in Java. So followed by that, we'll dive into the next question, that is, what happens when the main method is not declared as static? So the answer for this question is, when the main method is not declared as static, then the program may be compiled perfectly, but ends up with a serious ambiguity and throws a runtime error that says no such method error. So when you basically declare a main method, don't forget to specify the static keyword. So with this, we finish the beginners segment of questions. Followed by the beginners segment, we have the next segment, that is the intermediate level segment. So the first question in the intermediate level is, what is JDK, and mention the variants of JDK. So the answer for this question is, so JDK is basically an abbreviation for Java Development Kit. This is a combined package of JRE, that is the Java Runtime Environment, and developer tools used for designing Java applications and applets. Oracle has the following variants for Java Development Kit. So the first one is the JDK Standard Edition, which is normally used by beginners and intermediate developers. Next, after the JDK Standard Edition, we have the Java Development Kit for Enterprise. So this particular Enterprise Edition is used by professional Java developers for developing Java-based applications and frameworks. Now the last one is the Java Development Kit Micro Edition. Now followed by 21st question, we will dive into the next question that says, brief access specifiers and types of access specifiers in Java. So the answer for this question is as follows. Basically, access specifiers are predefined keywords used to help a Java virtual machine to understand the scope of a particular data member or data manipulating method within a class or outside the class. So in Java, we have 4 types of access specifiers. The first one is public access specifier. So when you declare a data member or a data manipulating method as public, then that particular data member or method can be accessible by any class or object throughout the package. Followed by that, we have the private access specifier. So unlike the public access specifier, when you provide the private access specifier, then the accessibility of that particular private data member or the data manipulating method will be provided to specific classes and specific objects only. And finally, we have the protected access specifier. So the protected access specifier is a bit more secure than the private access specifier. So the access for this particular protected data member or protected data manipulating method could be a little more difficult to access unless you are going to implement everything which is present in that particular package. So basically, if you are trying to access the protected data member or protected data manipulating method of a different package, then you need to first import the package into your existing package. So that's how the protected access specifier works practically. So finally, after the major 3 access specifiers, we have the default access specifier. So default access specifier will be provided by the Java virtual machine. So in case if you declare a variable or a data manipulating method without using any specific access specifiers that are public, private and protected, then JVM implicitly considers the default access specifier. So there is no much of a difference between the public access specifier and the default access specifier. Both have the same functionality and accessibility. So followed by this question, we enter into the next question, that is, can a constructor return a value? So the answer for this question is as follows. Yes, a constructor can return a value. It basically returns the current instance of a class implicitly. You cannot make a constructor return a value explicitly, but automatically it returns the instance of a class. So the next question is, explain this keyword in Java. So in Java we do have a keyword which is called as this. So what does the keyword this mean in Java is the question. So the answer for this question is, the term this is a special keyword designated as a reference variable. So the term this keyword is used to refer to the current class properties like data manipulating method, instance, data member and constructors. So followed by the 24th question, we have our next question that says, explain super keyword in Java. So the answer for this question is as follows. The term super is a special keyword designated as a reference variable. So similar to this keyword, even super keyword acts as a reference variable. But the difference is super keyword is used to refer to the immediate parent class object. So followed by the 25th question, we have our next question, that is, explain method overloading in Java. So basically method overloading and method overriding etc. are the concepts of polymorphism. So now let's have a correct answer here. So the process of creating multiple method signatures using one method name is called as method overloading. So for example, consider that you wanted to include an addition operation in your program that performs addition operation. So the first method will be having the name add, and inside the method parameters you'll be having 2 integer types of parameters. Similarly, you wanted to perform another addition operation with the same name add. So here you will provide the method name completely same to the first method, but inside the parameters there is a difference. You are adding 3 parameters here. So when you pass the values to the add method, then which method to be overloaded? That's the confusion, right? So should I overload or should I execute the first add method or the second add method? So this completely depends on the number of parameters you pass. If you are passing 2 parameters, then the first method will be executed. If you are passing 3 parameters, then the second method will be executed. So this is how the method overloading happens in Java. So the process of method overloading can be achieved by using 2 different ways. The first way is to change the number of arguments. So that's what exactly I've discussed before. Now the second way is varying the return type of the method. So with this, let's enter into the next question. Can we overload a static method? So as discussed before, the values of the variables or data manipulating methods will not be changed when we have used the keyword static in front of it. So the question is, can we overload a static method? Now let's discuss the answer for this. The answer is no. Java does not support overloading of static method. The process would throw an error reading static method cannot be referenced. So followed by this, we have our next question. So the next question is define late binding. The answer for this question is binding is a process of unifying the method call with the method's code segment. Late binding happens when the method's code segment is unknown till the method is called during the runtime. So followed by this, we have our next question. Define dynamic method dispatch. So the answer is the dynamic method dispatch is a process where the method call is executed during the runtime. The overridden method is called through a reference variable of superclass. So this process is called as runtime polymorphism. Now we have our next question. Why is delete function faster in linked list than an array? So basically linked list and array are the Java collections, or in other words, it's also considered as data structure. So to answer this question, you need to understand the analogy of linked list and array. So basically an array is a complete memory block of consecutive memory locations. So consider that your memory location starts from 100 and your array has 10 locations. So it's a complete reserved block of from 100, 101, 102 to 109. So you have 10 memory blocks. So in case if you wanted to add a number or delete a number, then you had to make changes to the complete memory block. But when you come into linked list, you have the memory blocks used from the memory heap. So basically what you do here is you basically connect the nodes through addresses. So in case if you wanted to eliminate a number, then what you do is just to manipulate the addresses. So the address of the consecutive node will be changed. So that's the only change what you make. So now this is the reason why the delete function or any kind of manipulation function is faster in linked list compared to array. So now let's have a brief answer on this. Delete function is faster in linked list as the user needs to make a minor update to the pointer value so that the node can point to the next successor in the list. Now followed by this, we have our next question. Give a briefing on the life cycle of a thread. So the life cycle of a thread includes 5 stages, which are as mentioned below. Newly born state, runnable state, that is it provides the JVM with a feedback that I'm ready to run now, followed by that the running stage where the thread is actually running, followed by that the block stage. So basically the thread will be blocked for some reasons, for some intermediate output or something, if the thread is waiting for an input from another source or something similar. So that's where the blocked state comes to existence. And finally the dead state. Once after everything is processed, the thread is eliminated by JVM. Now followed by this, we have our next question that says, explain the differences between the operators provided here. So the operators might look similar, but they are different. Now let's understand about these operators in a much better way through the answer. So the answer for this question is, although they look similar, but there's a huge difference between them. So the first operator, which looks like 2 greater than symbols, perform the operation of right shifting. So when you provide a binary number or binary value, then the bits will be shifted towards the right. And the second symbol or the second operator, which is having 3 greater than symbols, is used to shift out the 0 filled bits. So this is the functionality of these 2 operators. Now followed by that, let's have the 33rd question. Brief the life cycle of an applet. So the answer for this question is, the life cycle of an applet basically involves the following stages. The first stage is the initialization stage, next is the start stage, third is the stop stage, fourth is destroy, and finally we have paint. Now the next question is, why are generics used in Java? So the answer for this question is, compile time type safety is provided by using generics in Java. So this approach allows the users to catch unnecessary invalid inputs at the time of compilation. Generic methods and classes help programmers to specify a single method declaration, a set of related methods, or with a single class declaration, a set of related types. So followed by this, we have our next question. Explain externalizable interface. So the answer for this question is the externalizable interface helps with the control over the process of serialization. The externalization interface incorporates read external and write external methods. So we have listened to a new term here, which is serialization. So what exactly is serialization? Serialization is a process of sending your Java code or Java project from one computer system to a different computer system. So basically, if you wanted to execute some kind of Java program from a different location, then you serialize this particular code to a different location where you actually want to execute, and this particular process of transferring your code is called as serialization. Now the next question is, explain daemon thread. So the answer for this question is, the daemon thread can be defined as a thread with least responsibility. The daemon thread is designed to run in a background during the process of garbage collection in Java. The setDaemon method is used to create the daemon thread in Java programming language. So we have our next question now. Explain the term enumeration in Java. So the answer for this question is, enumeration or enum is an interface in Java. Enum allows the sequential access of elements stored in a collection in Java. Now the next question is, why is Java considered as a dynamic programming language? So the answer for this question is, Java was designed to adapt to an evolving environment. Java programs include large amount of runtime information that is actually used to resolve access to the objects in real time. So this is the reason why Java is considered as dynamic programming language. Now followed by this, we have our next question. Can you run a code before executing the main method? So the answer for this question is, yes, we can execute any code even before the main method. We will be using the static block of code in the class when creating the objects at load time of the class. Any statements within the static block of the code will execute it once while loading the class, even before the creation of objects in the main method. Now the last question in the intermediate section is, how many times the finalize method is called? So the answer for this question is, the finalize method is called by the garbage collector. So for every object, the garbage collector calls the finalize method just for once. Now with this, let's enter the advanced segment of interview questions based on Java. So the first question in the advanced segment is, can the keywords this and super be used together? So the answer for this question is, no. This and super keywords should be used in the first statement in the class constructor. So the following code segment will give you a better idea. So you can see that we have used the keyword super and this in the class constructor. That is the first class constructor. Now this is how you can use super keyword and this keyword together in case if you wanted to use. So with this, let's continue with the next question in the advanced level. So the next question says, explain JSP page. So the answer for this question is, JSP is basically an abbreviation for Java Servlet page. So the Java Servlet page consists of two types of text. The first is the static data and the second one is Java Servlet page elements. Now the next question is, explain JDBC. So the answer is, JDBC is an abbreviation for Java Database Connector. JDBC is an abstract layer used to establish connectivity between any existing database and to a Java application. Next question is, explain the various directives of JSP. So the directives are instructions processed by JSP engine. After the JSP page is compiled into a servlet, directives are used to set page level instructions, insert data from external files and specify custom tag libraries. Directives are defined between the following symbols. So these are the symbols that are used to specify the directives in a JSP page. The different types of directives are shown as below. There are three types of directives. They are include directive, page directive, and taglib directive. So include directive includes a file and merges the content of the file with the current page. The page directive is used to define specific attributes in the JSP page like error page and buffer. The taglib directory is used to declare a custom tag library which is used in the JSP page. Followed by that we have the next question. What are observer and observable classes? So the answer for this question is objects that subclass the observable class maintain a list of observers. When an observable object is updated, it invokes the update method of each of the observers to notify that the observers that it has changed its state. The observer interface is implemented by objects that observe observable objects. Might be a little confusing, but you need to read this answer once again. You can pause it and you can read this answer once again so that you can get a brief understanding of this. Followed by that we have the next question. What is session management in Java? So the answer for this question is a session is essentially defined as the dynamic stage of a random conversation between the client and the server. The essential communication channel includes the string of responses and requests from both sides. Typically, the most popular way of implementing session management is the employment of a session ID in the communicative discourse of the client and the server. The next question is brief about Spring Framework. Spring Framework is basically the framework of frameworks. Now the answer for this question is Spring is essentially defined as the application framework and inversion of control container for Java. Basically, the chief purpose of Spring Framework is to create enterprise applications in Java. Also, it is especially useful to keep in mind that the central features of the Spring Framework are essentially conducive to any Java application. So the next question is explain JCA in Java. So the answer for this question is JCA is basically an abbreviation for Java Cryptography Architecture. So JCA provides a platform that gives architecture and APIs for encryption as well as decryption. JCA is used by the developer to combine the application with the security measure. It also helps in performing the third-party security rules. It uses the hash table, encryption message digest, etc. to implement the security. So the next question is explain JPA in Java. So the answer for this question is JPA stands as an abbreviation for Java Persistence API. The JPA is enabling us to create the persistence layer for desktop and web applications. JPA deals with the following: Java Persistence API, Query Language, Java Persistence Criteria API, Object Mapping Metadata, etc. So the last question in our list is explain the different authentications in Java Servelets. So the answer for this question is authentication options available in servlets are as follows. The first one is basic authentication. So the basic authentication consists of username and password provided by the client to authenticate as the user. The second one is form-based authentication. In this particular type of authentication, the login form is made by the programmer by using HTML. Followed by that, we have the third type of authentication, that is digest authentication. Digest authentication is similar to basic authentication, but in this the passwords are encrypted using hash formula. This makes digest more secured. And lastly, we have the client certificate authentication. The client certificate authentication requires that each client accessing the resource has a certificate that it sends to authenticate itself. This requires SSL protocol. Thanks to our training experts. Hope you found this tutorial helpful. With that note, we have reached to the end of this session. If you have any queries regarding this tutorial, or if you feel you have a suggestion for us, then please feel free to drop it down in the comment section below, and our experts team will be happy to reach you out. This is Ravi signing off. Until next time, thank you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.